A very good afternoon to one and all as we gather for the day 5 of our 6-day online faculty development program on cultivating innovation AI in healthcare, organized by the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, Salem campus, Salem. Day 5 was indeed a remarkable day of learning, filled with cutting edge discussions and transformating ideas that explored the frontiers of artificial intelligence in healthcare systems. The first session delivered into the introduction of AI for remote patient monitoring. The research person emphasized how these technologies are redefining patient care paradigm by enabling real-time health tracking, predictive diagnostics, and personalized treatment plans. The discussion illuminated the significance of connected healthcare ecosystems and the potential of AI-driven IoT solutions in ensuring proactive and preventive care of patients across diverse geographies. The second session focused on deep learning and computer vision applications in healthcare, which was nothing short of fascinating and intellectually stimulating. We explored how advanced neural networks, convolutional model, and image analysis technique are revolutionizing medical imaging, disease detection, and clinical decision-making processes. The practical insights provided into AI-proven diagnostic accuracy, image segmentation, and anomaly detection truly reflected the transformative potential of these technologies in enhancing the efficiency and precision of healthcare delivery. The interactive discussions, live demonstrations, and real-world case studies in both sessions not only broadened our theoretical understanding, but also provided a pragmatic perspective on implementation challenges and future research opportunities in these domains. In summary, Day 5 offered a comprehensive view of how technology driven innovations ranging from ensure patient monitoring system to deep learning powered medical imaging are paving the way of next generation healthcare solutions. We sincerely thank our eminent resource persons for their erudite presentations and thought provoking, which have undoubtedly enriched our knowledge and inspired us to explore new dimensions of research and innovation in healthcare technology. Thank you.
A very good afternoon to all distinguished dignitaries, esteemed resource persons, respected faculty members, and enthusiastic participants. It is indeed an honor and privilege to welcome you all to the 6 days online faculty development program on cultivating innovation AI in healthcare, organized by the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, Salem, under the aegis of AICTE Atal Academy. Today marks a momentous occasion, the cultivation of insightful and intellectually stimulating 6-day academic journey. Over the past week, we have traversed through cutting-edge innovations, research-driven perspectives, and transformative discussions that have illuminated the future of AI in healthcare. It is now my privilege to introduce the dignitaries who have graced us this occasion with their esteemed presence. To begin with, I request our respected HOD of Ai&Ds and the coordinator of Atal FDP, Dr. R. Rekha ma'am, to introduce our first distinguished chief guest, Engineer V. Arun Kumar sir.
Let me introduce our Mr. Arun Kumar Vishwanathan, a highly experienced professional with over 20 years of software development. He has a strong background in private data centers, network management, visualization, and hyperconvergence system. Mr. Arun Kumar is a master architect at Hewlett Packard Enterprise, a role he has held since June 2011. His work at HPE includes developing and deploying an enterprise private cloud and integrating various HPE hardware and software. He has also worked on several key projects such as the HPE General Private Cloud Enterprise, HPE Data Center Simulator, and HPE OneView Testbed as a Service. Prior to his time at HPE, he worked at Wipro Technologies for 7 years, from March 2004 to May 2011. During his career, he has held various roles including software architect, system specialist, and project leader. He has also gained international experience working as an on-site coordinator and individual contributor at Alcatel Lucent Canada include. Mr. Arun Kumar's technical expertise includes programming languages like C, C++, Java, and Python, and he is proficient in databases such as Oracle and SQL. He holds Master of Engineering and a Bachelor of Engineering in Computer Science and Engineering. He is also a certified professional, having earned his CCNA and SCJP 6.0 certifications in 2010. Please join me in giving a warm welcome to Mr. Arun Kumar Vishwanathan. Welcome you, sir.
Yeah, thanks, ma'am. Thanks for the introduction. Hope my voice is
Thank you,
clear,
ma'am.
madam.
I now invite Engineer V. Arun Kumar, sir, to address the gathering and share his valuable insights.
Yeah, madam, please confirm whether my voice is audible.
Yes, sir.
Yeah, okay, thanks. Yeah, I can go ahead and share my screen, right?
Yes, sir.
Okay. Okay, can someone confirm whether my screen is visible?
Yes, sir.
Okay, thank you. Yeah. Yeah. Good afternoon. Good afternoon, everyone, and good morning to good morning and good evening. People are from different time zones. Yeah. First of all, I want to thank Mahindra Engineering College and the staffs of Mahindra Engineering College for giving me this opportunity to share my new thought process about a session on an EE about the wearable devices. Okay, and one more thing to point out was like I'm also an alumni of Mahindra Engineering College. I did my BE from Mahindra Engineering College. So okay, and today's topic is about wearable technology and the role of AI on the wearable technology to see like how in real time we can watch the data and what is the benefit it is going to bring up for the humans. So that is the topic for today. And then and it is me like who the presenter for today is like Arun Kumar V. Most of my experience and everything Rekha madam had been covered in detail. And to add up that I'm having 20 years of experience, and I've been as of now I'm having a master expertise in building private data centers. And as like you or as like others, like even I do have an started digging my interest over towards an AI technology and trying to adopt how the AI can be used in at least the work of what we are doing, right? How it can be helpful and what is the problem it is really solving for us. We are actually focusing on that. That is really like I started my journey with AI. And to be honest, right? So it has been actually helping us a lot. So that's about the advancement of AI. Okay. So since we are touching the medical part of the system, right? And of course, I'm not a doctor, right? So I want to start with some disclaimer because The presentation indeed here, like whatever that we are presenting here, it is mainly for informational and educational purpose. Since it is a medical system, we can't take that advantage, right? So, and also I'm not a doctor to give medical advices, although I'm not getting into very deep, but in fact, I want to play a safe game. So that's the reason I'm putting up this disclaimer. So the technologies and approaches discussed are not intended to replace any professional or like in what medical services, right? It is about our thought process and how the things, how the technologies can be used or advanced the medical system. That is the intention, right? So some medical terms and concepts that whatever that that I'm going to call out on the slides, right? All these terms are pretty much to the best of my understanding. Okay, sorry for the distance. Okay, it is explained to the best of my understanding, and I'm not we are like as individual persons in the team, right? And we can't take a cover of it is like a fully clinical and technical correct. So that is a disclaimer I want to put up before touching the medical systems, and which I'm going to talk about certain things back into the slides. Okay, wearable tech. Let me start with some introduction. Wearable technology today, like it is not something new to us, and each and everyone should be coming across or been using it across day in, day out, right? And pretty much one best example, what I can call out is in smartwatches. So people are being very much interested to get new smartwatches and then start wearing and using it for different purposes. I don't want to call out like exact purposes, but yeah, some people use it for different purposes. And pretty much one what we have been seeing in front of us, which has been very much been used by everyone, is in smartwatch, right? And then, of course, this devices, whatever we are calling it a smartwatch or whatever smart devices, right? It comes with like phone sensors to read the I/O and then processors and connectivity features, right? The connectivity features mainly, even a smartwatch can connect to our mobile phones or it can directly connect to the internet if it has a SIM on it. Similarly, like it is having all the way, like the way we have been having a phone in our hand, it is also like one kind of smart device which can able to collect the data and provide the data outside, and it also do some processing, right? So common examples include smartwatches, smart rings, smart glasses, etc. And typically, another thing that whatever we have been seeing, not very, not been very popular with many people is a fitness trackers. I know people who goes to gym and who have like an regular health checkups, right? Those kind of people, I had seen they have been wearing fitness trackers. And how much of data it has been taken out to do the data analysis, that seriously, that numbers we don't know. But we had seen peoples who have been using fitness trackers. And additional to that, we had seen people wearing medical devices. And I'll once I get into the slides, I'll talk about like what are medical devices and what are those and what are the purposes are. Yeah. Typically, medical devices, some people will wear it all the time, and some people will wear it only for a particular amount of time just to detect certain things. Are like if the data which has been collecting on time is not being correct, so on time is not able to predict exactly the thing about any diseases. That's where like we want to use a medical devices to collect a real time data. So medical devices, it's always an on and off devices. So it is not everyone will wear it all the time. So that's the kind of things. So application span across, right? So as I told about fitness trackers, it's mainly sports person and typically like smartwatches, right? So it is of lifestyle enhancement, right? And then medical diagnostics, workplace safety, and health and fitness monitoring. So typically, like we have been talked about this in detail in the last slide itself. It is about smartwatches, fitness band, and medical devices, right? Smartwatches, and a few examples that what I was we seen across is like Apple Watch, Galaxy Watch, and in fact, like there are many small vendors who have been creating a smartwatches of low cost, but we are not sure like what quality of sensor have been used, how much of data capture on it is really accurate. So that is a problem with the smartwatches, which has been generated by an like low band or like which has been created using a low level sensor. And coming to the fitness band, yeah, the fitness band it is mainly for track the fitness, and it in fact there will be a lot of schedulers that you can do. That schedulers can able to ask you to drink your water in time, and the schedulers can even able to inform you on many other things based on your medical experience or how your day has been passed. So that's why fitness band can do something extra than smartwatches. And medical devices, as I was explaining before, right? It is for some people will want to have an BP monitoring. The reason is like if for some people the BPs will be rising up and rising down, and it is not been stable over the day. In that cases, what doctors, mainly the cardiologists, advise us to wear a continuous BP monitoring for a day or two. With the day or two, it will watch your continuous day patterns, and then it come up telling that yes, you are having a real BP, and what is your variations of your BP, and what is the kind of tablets they can prescribe for it. That's why medical devices, right? And then like insulin bumper, right? So insulin, what it does is right, it will be kind of a device that has been attached to your body. It have a pick on your body to get your blood to understand what is your blood level, and then based on that, it just induce the level of injection insulin back into your body. That's what it is. Those insulin pumper are the device that can be weird always. And the continuous BP monitoring is being weird on need basis. So that's why these devices are being categorized. So evaluation of wearables. So in last two slides, I was talking about wearables, how it has been evolved, right? So it is like in simple fitness trackers, and then later it came smartwatches. Smartwatches, like what has been purposes for fit and fitness trackers and health monitoring devices. All the three things that we've been talked about in previous slides. And what is next? That was a big question, right? So what's next? Like what had been really evolved, and what is next, and how much it has been evolved? That is pretty much we are going to cover a little bit on this based on my understanding, like we are going to cover up on this mainly in the next one hour session, right? So limitation of smart devices, right? So we have a smart devices. Talk to like what are the benefits of it, and what are the health benefits that it has been bringing in, right? Smart devices have rarely saved lives on their own. That is a real fact, right? It is always in less than percentage, right? The main reason is like we wear a smart device. We do have an habit like in simply touching the phone and checking for messages. Even we do have an habit when we have been wearing a smartwatches. We do go to our watches and simply check our BP monitoring, our SpO2 oxygen levels, right? But how much we really believe on the data? How many people, when we've been seeing the data, had been went to doctor immediately telling that my smartwatch is reporting that my SpO2 level is less. And in fact, we are not doctor. We don't know what is the data that is necessarily been a threshold after which it goes down. It has been conducted as an like SpO2 loss, right? Even we never knows that complete medical record as well, right? So what that means that it collects data. Smart devices can do based on the accuracy of the data depends on sensors, whatever it is used, but it detects the data and it shows the information to you, but it never predicts. It never predicts in the sense, right? It has been never collect the history of data and telling that there is something bad could happen, or like we have been 100% perfect in doing things, right? So that's what we mean. These devices are not a lifesaver, at least till now, right? The smart devices, right? So wearable devices generate vast amount of health data. As I was been telling, when you have been detecting, whenever you have been running your SpO2 level, or like you have been checking your BP using your smart devices, it just creates lot amount of data, right? And as per scientific terms, right, it is still a raw data. It doesn't convey any meaning unless it has been taken and processed, it, right? It just says that in type data whenever you fix it, so it just tells the data and it goes up. Okay. And medical professionals will never ready to accept the data, right? They state about the wearable data. For example, if you go to a doctor and say like my phone, my wearable devices, it's been a watch, whatever I'm wearing, right? So it has been showing my SpO2 level as less. Can you diagnose me? Surely the doctor will not go for your watch, because the doctor will go on and continue his diagnosis by putting his oxygen meter, or like takes the ECG, or by takes your BP meter, and then that's the way the data generated by smart devices. That's where it is today, and it is not the trustable data. Yes, of course, we say data, but it has not been convenient in the form that it can be readily acceptable, right? So what that gives a very clear clarity on smart device alone aren't enough for us to see like forthcoming things, right? So that's a need for a system that bridges the gap between customer graded data and clinical graded data, right? So what are the customer graded data that what are generated for the thing, and it has not been clinically equivalent. So we need some technology on the top of it which can take this and make it as a clinically better, or like clinically comparable, which doctors can accept, right? Making wearables more predictable and useful in healthcare, right? That's the intent, right? So of course, the world has been growing, a lot of new technologies coming in, and AI integrations, right? That is the point that we want to go with. AI integrations on the top of smart health devices. That's been the topic for a day, and that is what been useful to overcome the problems that we have been seeing with the exact smart devices today, right? That's why we have been starting our journey now, right? So I know Rekha madam had explained about explaining like there are a lot of sessions happen on AI, so I'm not getting very deep into that. What is AI? It is a question which has like n number of answers. So I'm just leaving to your choice and definition of the way you want to define the AI. So I'm not getting into that part because they will have their own understanding, own observation of AI. That's the reason I'm not giving definition for AI, and it was not already discussed. But one thing that I want to put into the one information I want to put into it, smart devices or health trackers, whatever we are using is today is not an AI. That is what we have explained so far, right? So that is a misconception many people have said. So that is a misconception I really want to break, telling that smart devices and health trackers are intended to produce the data, and then all the AI advancements will come on the top of the data to do a predictive analysis for you, right? That's the main intent. So the integration of AI enables right time insights, predictive analysis, and personalized recommendation, right? These are the three things mainly what AI integration can do on the top of your data. It is going to do real-time insights, it is going to predict the things, and the personalized recommendation that has been very, very important. I will talk through it when we go into the slides. Okay. With the AI, the vast amount of health data convey a meaning now. Previously, my previous slides, I was telling that it doesn't convey any meaning, right? It was just a raw data. But when you apply AI, when you're going to see the insight of it, it is going to give a meaningful data for you by its intelligent interpretation. Right? The data are going to convert it to a form, and then the data will be taken into the form like where it can going to give us data about a valid health case, right? So that's why it is called as intelligent interpretations. AI transforms data into an actionable insights, right? So it's not about getting the meaning out of the data, but it's also what I can do with the data, right? It detects anomalies, predicts potential health risks, right? That could happen, and offers personal recommendation, right? So these are things how data has been getting converted into one actionable format now, right? AI-driven alerts and predictive models that enable timely intervention, right? The timing medical things is all about in time, right? Even many times we heard from a doctor telling that you brought the patient in time, and in fact we could have been saved the patient if you've been brought 10 minutes before. So timing plays a major role when it comes to a healthcare, right? So in fact, like that's what AI can help us over here. But how deep it's still a study that we nobody knows about it, but it is some way it is going to help us. That's why with the current advancement, that's what we are, right? AI create trust with the medical professionals when the data is contextualized, validated, and clinically relevant. When you take a raw data and give to doctors, nobody knows about it. But if it is in some system which has been approved or which has been trusted by the doctor, if you're going to feed the data, raw data into that system, and that system is going to give the some prediction to the doctor, that's where doctor believes it, right? That's where doctors even ready to act on it. That's why the raw data can be converted to valuable things by using. That's what AI is helping us over them. So that is pretty much about what and why AI is needed for us to make an wearables back into one health saving devices. That's what we have been going through. Okay. And of course, I have been talking about evaluation, right? So, and the evaluation continued, and the evaluation, right? Sleepness trackers, smartwatches, health monitoring devices followed that. Now we are into the stage where like AI powered wearables will doing a real time health insights and predictive analysis. So that's why it's all been evolved, and it has been still evolving because there are a lot of areas over here which people are exploring.
நான் கேட்கறதே இப்போ ஒரு ஒரு 1 hour உள்ள இருந்து
Okay. And that's why it's been continued. Okay. And this slide mainly talks about AI in the healthcare. Right? AI in the healthcare that we have been seeing lot of things, right? So even if you see like in hospitals, right, even in the advertisement boards, we are seeing that robotic assistance people are doing in surgery. For example, the knee replacement surgery. Now they have been telling that robotic assistants can do it. When I say robotic assistants, it is nothing but an AI driven, right? So AI driven things can able to find out exactly scan your bone and say like where it want to really put your knives to start your operation. So that's really like it is go to that extent and it knows where it need to open to do some any diagnostics or like to do any operation. That's where like that modern day technologies have been getting evolved in many hospitals right now in our hometown. So that has been very clear, telling that it is giving a very much support for a doctor. But one thing we need to like, it is not doing an operation for it. It is just a supporting system. It is not replacing doctors. It is just a supporting systems which is helping the doctors to do an operation. So don't whenever you see something called as robotic operations, right? It doesn't mean that robot is going to do the operation for you. It is going to be a supporting system for the doctors who is going to do that, right? So similarly, the way it is there has been AI system or a robotic system helping doctors to do an operations better. So it will be like used in different things like enhanced diagnostics, right? In algorithm analysis, medical data for faster diagnostics, right? So the challenge here is like, so I can get the data for last 3 days, right? With the 3 days of data that whatever I got, I can able to create a data for next 3 days to see like how bad your diseases can go, right? Or like, see, it is all forecast, right? So the first 3 days of data is real. With the 3 days of data, I can create next 3 days, 3 days of data. This 3 days of data is like in forecast. What that means, it can happen, but it can or it cannot be happen, right? So, but still, it is a forecast, but it is a valuable data for you in hand to take your actions upon. That's why it is going to help you on enhanced diagnostics, right? And on personalized treatment. AI customized treatment plans based on individual patient data. Yeah, that has been very important. When I was talking 2 slides back, I was been talking about AI does a personalization, right? So that's why it is like, see, not every patients are same, right? So based on that, every person needs a personalized treatment. So based on that, by your data history that will feed by the AI system collected from your body using this wearable devices, it can able to predict a kind of treatment that is especially needed for a patient to patient. That's what we mean that the personalized treatment. And as usual, predictive analysis, right? AI forecast, as I told you before, right? AI forecast devices, outbreaks, and patients' care needs. So that's what I have been talking about before when I will talk about it, right? So this is the role that AI in the modern world AI is playing on a healthcare. So coming back to the devices, we have been talking about wearable devices. We have been talking about different smart watches and things, right? So category wise are like overall, right? The devices has been wearable devices has been categorized into two types are like based on the purpose it's been used, right? So one it is called as in like consumer devices, and another one is called as a medical grade devices. So doctors have somewhat belief on medical grade devices, and doctors have zero belief on customer devices, consumer devices. That I think that has been very clear part. Even if you talk to doctors, they will tell. Okay, right? So consumer devices, it's mainly focused on fitness and life cycle tracking, right? And of course, it has been convenience. It is for you to just add on the data. So it is for you to just sync or hearing the songs, or you want to control certain things from your from your wearable devices. That's what it's pretty much is. Like consumer devices prioritize those kind of things. That is the reason whenever you are getting a watch which is of been convenient, where it has been fully like and too much applications loaded into it, or like too many things that it can do. It is pretty much for your convenience, and that doesn't they don't concentrate too much on medical systems, because even they know the data whatever they're giving out can't be 100% correct. But medical devices prioritize other things. It is about precision. It is about how precise it is collecting the data from you, and with the data, how much life saving it can achieve. That is what about precision and life saving on a devices. These are the two major category of wearable devices. Okay, so let me walk through these devices, and we'll see like how these devices can take in the data from it, how it can be converted to an application. That is where our journey is going to go now. So smart watches overview, which I don't want to get into very deep because you people knows about it. That's the reason like you people had done a lot of analysis before getting the smart watches, and every watches will comes up with it like what's pros and cons, and many features comes with many features comes with more money. So based on that, whenever you have been getting any devices over the internet or like over any shops, you do a lot of analysis. So you people knows very well about smartwatches and the amount of usefulness that is going to bring in back to your health system or like for your personal customization, right? So that is about smartwatches, right? So next bit about fitness band. Fitness band, many people must not be more aware of it because many people we don't use it. As I was looking, it is mainly for an activity tracking and health metrics and user friendly, right? User friendly in sense it's something about the connectivity, but it's mainly about activity tracking and health metrics. So in fact, what is it like the clarity or like an accuracy of data, health data. For example, if you take a sleep monitoring, the data collected from a fitness band is being more accurate than what has been collected from the smartwatches, right? So because the intent purpose is being completely different. As I was telling on the types, right? It is about convenience and lifestyle, and it is about precision and life saving. So that's a difference you want to say. So coming to the medical grade wearables, right? So which is being which what we talked about, right? It is ECG monitoring, tracks heart activity and health insights, right? So it tracks your heart activity and then it will see like it takes the data and it like predict some amount of data. Like see whatever the wearables that you have been having today, right? It is of being less compute power or like an it has been or a less CPU, right? So it can't it will have its own limitations. It is not going to take your last 1 month of data process and going to give you some notification on your watch to give a 100% accuracy data. So what that means like it tracks the activity and do the health insights with the least amount of data that whatever it is maximum possible. That's what it is going to do. It is not going to do you a AI application job like which has been running with GPUs or CPU heavy weighted CPUs, right? So it does just the job to an immediate lifesaver. It is not going to have a statistical view of a long time data. That is the first one. Next is like glucose monitoring, right? Glucose monitoring, real-time glucose level tracking for diabetes. As I was telling before, it just do some tricks. And modern day, even we are seeing apps which is coming in the Play Store telling that you keep your finger on the cell phone device so we can able to predict your blood sugar. Right? Of course, technically, no medical or like no doctors will accept that, right? Something which you want to be see on a physically presented in the blood can't be divided by you keeping your fingers over it, right? So that is not the case. But if your glucose monitoring is going to prick today modern days, right? It is going to prick your blood, which you won't feel a pain, right? So those kind of devices are really a trustable devices which you can trust, and those kind of things it can be wearable, right? So those are some things. And then finally about a health integration, right? Since I have been talking about ECG monitoring or glucose monitoring, the amount of devices it processes within that small devices, it is going to be very less. But that can be improved more when you come to when you have an integration with your mobile phones, right? Your mobile phones are being equipped with more processor and more CPUs. More CPUs are like more memory compared to your wearable devices. So the data analysis, what is done from your phone, can be more than compared to what is happening on your wearable devices. So typically, I was telling typically like what I mean over here is right where you've been processing the data and how much data you are processing is very important for you to detect something. So that's the reason you want to be go at one level up. So implantable wearables and advantages, right? Which we have been talking about pacemakers. This implantable is something which has been put back into the body always. One such example is pacemakers, devices that regulates heart rhythm. We know like some people have been diagnosed to have pacemakers in their body, which has been inbuilt, which has been kept inside your heart, and it keeps your heart pumping, right? So that is kind of devices it can be implementable. So that is also kind of an I don't want to consider as an wearable, but it's an implantable. So that is essentially for your life. That is essentially for run your life, right? And similarly, like insulin pumps. Some people will have an sugar or glucose which has been varying a lot. For example, some people, right, the sugars can shoot up immediately after the food. For some people, it shoots up after 4 hours after food. It depends on persons to person, right? So typically for such kind of persons, this insulin pumps have been very, very important because a sudden shoot of sugar can affect other parts of the body as well, right? So yeah, it shoots up and you go and reduce it. That is not a deal. Yeah, and it is not bad as in low sugar, which will make you to think. But the high sugars, once it shoots up, it can be regulated. But the problem is like whenever it shoots up, so it can able to spoil other parts of your body. That is the reason this insulin pumps have been over there. and the data it has been providing there, right? So there is no clue like how much data it is also injecting for every pump. So we want to take a data from this insulin pumps and we need to measure back in the system and say like what was your sugar after the food and how much it has been injected. So those kind of data it is available there. That's what I mean over here, right? So pacemakers and then health monitoring, continuous monitoring for vital signals and remote assistance. It's under like pretty much the same like whatever that you have been how AI is being used to this system. But typically about the pacemakers and the insulin pumps, this are two devices, right? So coming to smart, and as I was talking about, all these devices, whatever we talked about, it, everything operates based on sensors. When I say sensors, it's capable to touch your screen, take the data, pick your blood, take the blood, and take the data out of it, right? So all this have been happening by sensors. So real-time performance monitoring collects data on athlete performance monitoring. This is like smart watch sensors. This is what is about this. Like muscle activation tracking, muscle measures muscle usage and optimize training. So based on it, it just does like how much your muscles, how much you want to train. So injury prevention insights, right? Analyzes data to reduce risk of injuries. It says that like based on like how what was the sleep that you had, right? How much of you can maximum you can extend your those kind of data collected from the sensors, and then that will be feed and they will predict the systems accordingly, right? And then wearable sensor technology. There are different kinds of sensors, optical sensors, it's all light-based sensors, and then electrical sensors, and then motion sensors. So electrical motion sensors will track your physical activity. That's a like that. One example of motion sensor is like whenever you will twist your arm to see your wrist, right? Automatically your wristwatch will be powered on automatically, and it's going to give you the and it's going to flash that time or like whatever the data is, right? So that's kind of a motion sensor. It detects a motion and takes an action accordingly. And similarly, like light-based sensor, like optical sensors are being under development. It has not been fully adopted. So one such example of optical sensors is right whenever you have been testing your BP, right? So that time you'll see like on the back end of your phones, right? It will start blinking more, right? So that is kind of optical things that is going to inject it, and it is going to take a data out of it. And similar like an electrical sensors, mainly for health monitoring. Basically, I was trying to find out exactly like where it is in electrical sensors been mostly applied, but I didn't find any exact thing. But yeah, that's it. But there's such a sensors available then. So wearable sensors. So now we see devices. Now we see that when we see devices, we know each and every devices is generating a data, and the data has been getting generated by using the sensors, right? So far, it has all been a raw data even for us, right? So because AI has been not played a role over here as per our journey from the start of these slides, right? So now, what is AI can going to do with this data, and what is going to predict for us? That's all about the slides, right? See, now the raw data collected from both consumable devices, medical devices is processed, is essentially need to be devices processed to extract meaningful health insights. That's what it's going to do. Now the data has been collected. Now where it is going to do AI processing is something that we need to see, right? Whether it is on the watch itself or your phone, or it is somewhere in the cloud where it needs to do an extensive analysis, right? Okay. So that's all. I also explained like what is advantage on doing in different places, right? Similarly, the raw data now it has been collected. Now there is some AI processing is coming in. How where it is going to convert your raw data into a meaningful insights. That's where your machine learning comes into the picture and predictive analysis are the two components that has an intelligent interruption of health metrics. So I'm not getting into what is machine learning. I'm not getting into what is predictive analysis. You people knows about it. So it just takes the data and gets a convenient meaning out of it, right? How it typically happens, right? How it typically happens. It's all LLMs, large learning models, right? Compares incoming data with the learned patterns. We all know what is LLM and what it has been used and how it gets its intelligence, right? There are many LLMs in the market today, right? If you go to the Hugging Face, you can see like, of course, 2,000 to 3,000 models have been available over there. Each has been built for its own purpose, right? Some some models are being already trained for a specific purpose, but some models has to be taken as raw and then you need to train. Or some patterns are being like half trained, you will take it and make it and fit to your system. Similarly, it is way like when you have been selecting some models for doing your AI processing, it is necessarily how much of data you're going to put it and train your data so that it can be able to predict the things. That's where it is, right? So the pre-trained large language model compares incoming data with the learned patterns. That learned patterns what we trained the LLM, right? it can able to detect anomalies. When I say detect anomalies, when you're going to feed a system with a lot of training data, and you're going to say like 120, 80 is your normal BP range, right? And on incoming data, if it is going to detect something telling that which has been a variable other than like 80 to 20, then it is going to report that as been your BP has been shooted up, right? So that's why it is going to detect the anomalies and predict potential health risks. How it predicts health risks, like if you are going to tell that you are 120, your BP level, which is abnormal than like 120, 80, which has been continuing for a long time, then it is going to see that there is going to be a potential health risk. That's why it is going to predict. And it basically to trigger actions based on that, right? Trigger actions like sending alerts or notification, right? So the even if you have been monitoring data, keep on monitoring. If you go and keep on measuring your BP on your smartwatches, right? I'm going to measure now. I'm going to measure next 1 hour. I'm going to measure next 1 hour, and I'm going to continue this for the next 3 to 4 days, right? And in fact, even if you're going to do that, none of the smartwatches is going to tell you telling that in the last 30 instances of whatever you have been measured, this is the data I got. Based on that, your heart is unhealthy. None of the smartwatches is doing that today, right? That is the reason that smartwatches data will be transferred to either AI devices or something, which has been seized as an statistical data, or like it collects on timely data and predicts it out of it. So that's what the AI is really playing a major role here. It detects anomalies by comparing the data with whatever it is, and continuous detection. It's going to tell that what is a potential risk. And once it detects it is going to have a potential risk, it is going to notify in some way, right? So that's why it's all done, right? This AI techniques, whatever the LLM is doing, right? So how models is built, right? I'm not even an expert in building a model. I'm an I am an AI application developer rather than a model builder, but I know the fundamentals of models, right? So how every model builds is an abstract for everyone, right? So even like unless otherwise you are a data scientist, or like you are like a data engineer who like to understand how your data will be internally processed, right? We don't want to worry about much about it, right? So if you want to see like when you use the data, how best it is going to detect, that's why we need to measure a model, right? So based on that, you need to pick up the model for your things. Why I've been talking about that angle, like the AI techniques use advanced algorithm to forecast health events. That algorithms many times that be hidden inside a model, which has been kind of an abstract view when you're picking up any model for doing any of the predictive analysis, right? So that's why it is, right? Every model will have its own advanced algorithm, or some models will be running with an old algorithm but still do the prediction proper, right? So based on that, you can do one predictive decision making, timely inventions, and personalized health recommendations, right? That's what it is doing based on what has been stored over there. So and anomaly detection and the actions, which I has been going very deep into the last slide itself. It is about identifying irregularities, right? Using algorithms to find abnormal health patterns. When I say abnormal health patterns using algorithm, right? Algorithm is nothing but a mix and match problems, right? Mix and match. That's what the algorithms do. It takes the data, what has been feed into it as a like a test data or a threshold data. Anything that comes over that, that's why it compares and brings out the data out of it, right? That's why it is doing detects and abnormal health patterns. So monitoring health trends, keeping track of unusual health trends over the time, and then like proactive interventions, right? And proactive interventions is about taking timely actions based on the alerts from the irregular patterns, which I was been talking about, right? It takes the data about your statistic data and it discover telling that yes, your heart is in risk. That's why it is called as in proactive interventions. Before you are going to the doctor and seeing that, yeah, I'm having some pain in my chest. That's the reason I came to visit the doctor. Before that, even before you reaching there, right? It has been able to see your statistical data and then it's able to predict. That's kind of an anomaly detection and then continuous proactive actions based on that. So enhancing user awareness, right? So educating users on recognizing health anomalies, right? So with the systems in it, right? When you're going to measure it in your phone, obviously you want to be aware of what is the basic data, right? Whenever you're running the SpO2 level, you know, like more than 95% is good, or like when you're going to whenever you're going to run a ECG monitoring, or like whenever you're going to measure a BP from your phone, you are going to know like 128 is normal, right? That is why even users are being they are making aware of like what is the normal parameter that it will be if the data has been skipped from that normal parameter, that is where you're going to see some risk, right? That's where it is. So using feedback to improve detecting detection accuracy, right? Sometimes it is anything like anything is like in feedback loops. So sometimes what you see, right? Your data has been measured wrong, and then yeah, good example for that, which I can say over here, right? For a person, we know like medically 120/80 is a normal BP, right? But that is not true for each and every individuals across all the people in this entire world, right? Even we know some people who has been having 60/80, it has been always normal for them, right? For that kind of people, right? Whenever you're going to measure, telling that 120/80, measure against 120/80 is going to tell that your heart is in risk, right? But that is not actually correct because his body of the individual nature is like that. So at that point of the time, you need to feedback back to the system telling that this is the way you are going to train your LLMs, which has been actually monitoring your systems, going to tell that my detection, especially this is where like personalization also comes into the picture. On a personalization conceptual thing, on a personalization conceptual thing, so on the personalization things like you are going to feed a data back into the system telling that it has been a regular for me having 60/80 has been my normal BP. So your systems want to learn from that and it want to predict accordingly. That is what like integration feedback that you need to back into the system. By the way, you have been training the LLM based on the standard data against your particular data to fit the LLM, especially for fit the LLM to be personalized for it. That is something integrating feedback loops that you want going to do. So similar things I just did in the last slide, right? Personalization, right? AI-driven personalization is very, very important. Like as I told you, right, not all the humans is going to have the same thing. So it differs from person to person. Personalized health insight powered by AI allows for a deeper understanding of individual health problems. That is very, very important. That's the reason, although on the top of AI, we need a personalization. AI analyzes data from the anomaly detection to identify deviations from the abnormal health metrics to normal health metrics. It means that the normal health metrics can vary from person to person, but whatever I'm claiming as being for some person, it will be very rare cases. But that is not really, but it's not really true with all the humans. It is on very rare cases. For them also, we need to consider back into the AI systems under personalization. That's what I mean. So based on these insights, AI delivers customized recommendation. Yes, I need a customized plan for me. That's what everyone prefers. Customized treatment for me because I'm not the same for same like other humans. That's what the customization you can do. And intervention tailored to each user's unique health needs, right? That's what it is. And then it enables proactive health management and overall well-being. It's all about the general insights of like how AI can be used in the medical system, right? So I'm not getting deep into it. So data integration for research. So I have been talking about LLMs so far, right? How the LLMs will be trained, right? So it will collect a data aggregation. It combines disparate health data sources for competitive for comparison analysis, right? The amount of data that you want to collect from different people to train the LLM. And it's also very important when you've been collecting this data. It has been very important. Your data will be much more deviations. For example, when you've been collecting data, it is necessary. You want to collect your 60% of data from your if it depends on system to system, right? So, for example, if you've been creating a system, right, you want to put in combined data. What I mean is that you want to collect a data from different regions, right? The people's behaviors can differ from regions to regions. So, in that case, you need to take a data and, for example, you want to collect some data from an Asian region and some region from US external regions and some region from like an Australian external region. So like that, you want to collect a data from different regions. The diversity of data is very important to train your LLMs. It is not that, okay, if I'm going to create a medical system, I can go to collect the data only from Tamil Nadu and then go to do that, right? The patterns will be differ from the data compared to Tamil Nadu compared to Andhra. One example I will tell you, Andhra people will mean to eat more spicy food, but not as much as Tamil people. So similarly, the data will be different from people to people, right? So when you have been training LLM, it is necessary that you get a data from different zones or like different diversity because your AI system, when you've been learning them, you can able to predict, you can able to group people of different groups can have different number of behaviors. That is the reason whenever you have been feeding the data, even your region, location, those kind of things also matters. It's about like how your LLM sees it, right? It's all about seeing the data insights, right? So that internally how LLM works, we don't know, and also we are not being modern developer. But all this kind of simple parameters also is really very, very important when you have been training your LLMs, right? And that's enhanced research. Facilitate studies by providing researchers with rich data sets. When I say rich data sets, it is also in diverse data sets. Real-time insights enable timely data access for more responsible interventions, right? So real-time analysis is also very, very important. You feed a data, you train an LLM, and your LLM can able to serve the data real-time analysis by comparing all this data at a single structure. Privacy consideration, when you have been training your LLMs, you want to ensure that I have collected this data from this person. You can collect based on people from a region, but privacies need to be very much considered when you have been doing data. That is the reason when you've been training your model, you'll get a large data set. And first part of the set, what you do is like you will just discard all the data which is being personalized. You will choose in privacy, you need to remove all those things, and then you want to put the data back into the system for a training and interoperability. So ensure systems to work together seamlessly to improve data flow, right? The data feeds, it can be continuous data feeds. For example, like you'll be having LLMs, which has been continuously feed with data from different regions always, and it's also been keep on learning the things. When I say it is not a private model, it is like a public model which has been available in the internet. So it might be continuously learning. At that point of time, your LLM model has been sufficient enough to do the interoperability by collecting data from different sources, remove the data which is with privacy concerns, and then you need to train your models accordingly. So that's what the way we do in integrations in the LLMs. So application and case studies, health data analysis, patient-centric studies, we talked about responsive interventions and data privacy protocols, right? So data privacy and touch about like in limitations, right? Or like in what is the current problems in the current adopting AI, right? That time I'll touch upon data privacy protocols. Okay. So now we talked about data and how the LLMs has been modeled, and now we touch a little bit about real-time monitoring with the AI, right? So real-time monitoring that we know, wearable devices continuously track the metrics, provide instant feedback for health management. If it is only from your watch, I mean, like if it has been processing only from the watch, it will give an instant thing, right? And it doesn't do any like kind of an historical data, statistical data. Real-time data analysis, AI algorithm analysis incoming data to detect anomalies in health patterns, ensuring prompt alerts. Remote health monitoring, patients can be monitored remotely, diagnosed remotely, because the data about the patient is being flowing into the system, which doctors can see and then they can do it, right? And the decision support. AI-driven insights assist medical professionals. That is what I was telling, right? Robotics, AI robotics is helping doctors, not replacing doctors to do an operation. That's what it is. Enhanced patient outcomes. Real-time monitoring leads to timely interventions, significantly improving patients' health outcomes. That's what like monitoring data will do. So I'm getting little bits about like ECG and ECG insights, right? What it does, right? So basically, at high level, how it has been putting investment, right? I'll touch few things, right? So cardiac monitoring. So ECG plays a crucial role in detecting any problem with the hearts. By analyzing heart rhythms in real time, healthcare professionals can make informed decisions enhancing patients' care. So that's why those patients' care has been very important when you've been running an hospital. And with the continuous monitoring or like with the data that is having good insights, we can able to provide it. And integration of data aligns with previous applications with health data analysis and responsive interventions, ultimately improving outcomes of a patient. End of the day, like it watches to all your historical data and predicts the data well in advance to report whether you are in risk or not. That's what it is. And all the data is coming from your wearable devices as of now, right? So diabetes monitoring, real-time tracking, personalized alerts, data analysis, integrative approach and patient improvement, right? So I'm not getting very deep into it because all these are monitoring basically that what I see, mainly ECG monitoring and diabetes monitoring and respiratory health monitoring, right? This is something which I was talking about SpO2 level, right? Naturally SpO2 level, and also it's an asthma, right? Which has been very common now. It became a like very common problem with the people around, right? When I've been talking about the regions, right? Especially one touch point I want to take on here is right. If you see an asthma persons, they have been allergic to many cases, and it has also been very difficult to find out what they have been allergic to, right? For example, some people will be what to say. Some people will be get allergic or immediately they will get an asthma effect when they will smoke and crackers, whatever the firms that comes out of the crackers, right? And some people will have an allergy towards, if some people has been using a perfume, some other people nearby is using a highly strong perfume, right? It will create a problem for asthma patients. And in fact, not in our countries, it's not common in our countries. Even somewhere in foreign countries, people have been allergic to peanuts. Even in buses, they mentioned, right, don't eat peanuts in buses. So some people live in allergic to this, right? So that is also a key, right? So that is where when we have been training LLM, this data matters. How it matters is when I was telling you to put a diversified data to learn your LLM, when you're collecting a data from different regions, of course, you will be collecting data from a different regions where the pollution is very bad. For example, in Delhi, right? We see that pollution are bad. There are a lot of actions happening to make it better, right? For asthma patient, right? For asthma patient, it is not recommended to travel to Delhi, right? When their body is in very bad state. And it can monitor your data and it can tell in advance you are being into a red zone, right? Or you are into red zone where your asthma can trigger up. So how that will be possible? Only by doing a real-time analysis. Like your data has been continuously feeding, and your data also been monitoring where you are in reach, because you have been switching on your location, and your system knows that you are already an asthma patient. When you have been an asthma patient, when you have been entering into the region where your air quality is very bad or it is very populated, you will get the bill in advance. You will get an alert in your phone or your personal devices telling that you have been getting in a red zone where the pollution is bad, and you are going to be have your asthma, or like you are going to have your breathing problem, right? Even that helps the patient to have an inhaler in advance with a less quantity. For example, like when the people has been have a breathing problem, sometimes I know they'll be using more power to bring it down immediately because that is the immediate remedy, right? So, but if you have been getting a warning telling that you being an asthma patient and you have been getting into the red zone where the alert where you might be end up getting more, where you end up getting a breathing problem, you will be started using your inhalers with less quantity. That ensures that you are not taking too much of foreign bodies foreign bodies into your body. So by you have been saving your body as well. So in that way also it helps. That's the main point that I want to bring to over here, right? How the AI is playing a role by collecting this data, right? That is all about it. So SpO2, we already talked about it. And then sleep and stress monitoring. Yeah, this is really very, very important part in the modern world, right? We know we people don't have a proper sleeps. And of course, sleep is been the main reason for your stress level increase, right? So sleepness trackers is very, very important on your modern devices, on your wearable devices. So how much it really helps also very, very important, right? Sleep stages tracking, monitoring quality and duration of various sleep stages, right? So when I say sleep stages, how much you have been sleeping in daytime, how much you have been sleeping in your night time. Sleeping at the right time in night is very, very important. Then whatever, but you are trying to compromise that by sleeping in a daytime. There's no way it has been equivalent. That's why it compares and tells that result. Sleep and stress management. So mental health indicators, right? Analyze changes in mood and anxiety levels. There are people like stress mode, right? Like based on your sleeps, people can able to stress, like the monitoring, right? Based on how you behave, right? So it can be the way you behave that can also be stress that can be measured, and then it can be compared with your sleepness. So since you have been not slept properly last night, it is going to induce you telling that don't take up anything or don't get into your bad mood. Surely it is going to increase your stress. So those kind of things also it can alert. Sleep disruption notes notify users of a significant sleep disturbance. So it's like how much you have been disturbed back into your sleep last night. So that's about it. Stress level monitoring. Access daily stress levels throughout biometric data. Right? So restorative sleep sites and personalized recommendation. Personalized recommendation on AA plays a major role, which I have been tracking from the first. So personal recommendation is very important, right? Okay. So far we have talked through devices, data, AI analysis, and everything we have been talked through. How data has been fetched there using monitors, using sensors, and data has been predictive analysis, and how it has been getting informed. Okay. Now let us burn our hands into a little bit about it. How, as an engineer, how are we going to convert this back into an applications, right? Or you can ask whether I can build my own applications, right? And typically, my scope of study is more towards, like as I told you, right? I'm personalized. I'm expertise in building the private data centers, right? So what means, like, we know the data, how much it has been important to private. So it is all about how can I create my own private data system for doing my core health analysis, right? So that is about this data system, right? So those are some things that we are going to see about, like what A is really doing, right? So we have been seeing so far data collection and everything. How it can be converted back into an application. That's what I'm going to touch point about this, right? So A workflow. That this some term that you people might have been seeing through when you've been seeing through a lot of this. And what it is exactly, that is what little bit I'm going to touch, right? Up to this point, we have explored how data is collected, monitored, and used to trigger notifications, right? But we haven't yet discussed how these components comes together to form a complete AI applications. Now I'm touching bit about how I can build an application, which we really named as an AI workflow. There are many tools, frameworks available to do that, right? So mainly when I say workflow, it is a step-by-step process. It is not something new, all you people know. So basically, it starts with the process of data collection. Variable devices, that's what you collect the data from the variable devices, or like your data will be fed into a cloud, and from the cloud, you are going to collect the data collection. And then data transmission, the data securely transmit to a central processing system or cloud platform. Say you put a data back into the cloud, and if you have been building a separate workflow, private workflow for you, the data will be taken out from the cloud. So that's about this. AI-based processing, like machine learning and pre-trained models, analyze the data to detect pattern anomalies and trends, and it gets into the insight by using the AI generates personalized health insights by going through the data and with the help of LLMs. Yeah. AI and LLMs bind together, right? There is no AI without LLM, and the LLM is being based for AI, right? And forecast based on users' historical and real-time data, and based on that, it will go to the notification alerts. And as I told you, right, you can make your learn systems because you are in the workflow and you are building your private workflow and you have been building your own AI applications. You can put in the feedback and you can make your LLM have more insights so that you can come up to a much more level, especially for your personalization. That's why it's about feedback loop, right? So it's about, now we are touching a little bit about AI application, right? So when you have been building an AI applications, you will end up touching on AI, how the applications have been getting generated. See, please don't go deep into it. This slide I just clicked for your reference. So you people might have been already knowing about this. So what is meant by RAG and what is the problem it is solved on the top of LLM, right? So I've just touched basis because when I want to talk about an application or like AI framework, these terms I might be using in and out. That might be the reason I'm keeping it. So RAG, as you know, or any LLM that has been coming up today, it has been cut off, it is having a cutoff date. For example, ChatGPT 4 or like ChatGPT 5 or any of the private model, right? It says that my cutoff date was this. So any data which comes after that, right? It is kind of this LLM doesn't know about anything about the date after the cutoff date, right? That is why it has been always limited with your knowledge based on the cutoff date. But there are systems, right? I'm having an AI model, but I want to make it more advanced. I want to tell the more data from it. For example, this is mainly used in the case of generative AI, right? Generative AI can create with some good content or like some professional content form, right? But that is not a case where you can feed your data and get it, right? You can say that I can feed my data into my prompt of ChatGPT or ChatGPT, but that is limited. You can't copy paste a big PDF file back into the prompt because the prompt have a limitations of number of tokens. So in that case, you want to set a context to the your LLM and then you want to derive the data out of it. That is nothing but it is called as a retrieval argument generation. It comes from the name. You retrieve a data from other source from where you want to get it from where, which is going to serve as a context back into to your LLM. So for example, you're going to retrieve data from your PDFs or from your local documents somewhere. And then you are going to augment your AI. You are going to enhance the knowledge of your AI by giving the document back to the system as a context. And you are going to ask the system to generate the new data out of it. Why am I mainly bringing over here? This kind of things will be very helpful in our health monitoring. RAG can be used, I mentioned that over here. Retrieve medical guidelines or historical health records. For example, if you want to feed more data about yourself into your medical system or your LLM, that's why you're going to do this. You're going to take it as a RAG and you're going to install it. So, and you will making it as a like context aware. Now using LLM, client model doesn't know about any context. By feeding the data, for example, you're taking all your medical reports and feeding it back into the systems. That ensures that you are making your LLM or private LLM to context aware of your health data. That is why RAG will be used in your modern day application development. And AI agents. AI agents itself is a self-learning system. It does, when I say agent, it has been kind of an decision-making engine instead of a human. That's why we can call it as, right? An agent can do a job like it can go and get a data from different devices. It can take its own actions based on whatever the knowledge it has. It can do a number of lot of things. The main intent of using agent is to replace the humans in taking a decision there, right? So that's that the decision making that not going to do a task for you, right? It can execute certain things, but it is not like a human doing task. It is not going to do. Human doing complete task it will do, but it can act as like an agents. It can be act as like an agent for you. That's why it is the agents. These are the terms which has been pretty much getting used in the modern day AI development application, right? AI application development. So in the medical systems, it can have like an very things like agents can be modular, handling specific tasks like anomaly detection, calendar scheduling, and feedback logging. That's what we do, right? So finally, we are seeing that there is something called as agents. The difference between agents AI and agentic AI is like when you build a system with more than one AI agent, that is called as an agentic AI systems, right? That's why it is. And kindly, I wasn't talking about AI agents and agentic AI, right? And there should be some framework which has been integrating all these things. And that framework is called as N810. It is a framework for building an AI automation workflow. You can go through that articles and then you can find it out exactly like what are the things like it has like many functions in it, right? I'm calling out certain things here. It is
Yeah, automatic checklist.
hello, is there any questions around? Okay, let me put it. So you can refer to the site because of time, because time is a constraint. I just want to rush it for my slides. Yeah, you can refer to this. You can do it. So yeah, this is way it's going to be how our whatever we have been spoke to so far, right? How this can be converted back into an application as an workflow, right? So our step one, we'll see. This is the N810. We can build an agent. With that agent, you can see like webhook trigger. With that webhook trigger, it is going to be the data that is going to come into your AI systems or like an AI airflow. And the data pre-processing. Data pre-processing is going to remove the noise in the system or like the data which has been private data. Those things it will be removed. And then third step, you need to like identify unusual patterns in health metrics. So it can call some other models to do that action. Plus, it's in workflow. It can go in different paths to different actions, and it will finally give an output for it. Read through like N810 framework. It is like that framework you can do without any coding. It is like in programmatic drag and drop kind of systems. It will say like how you can build a agentic system over there. Like it will do an anomaly detections. It will do an insight generation by talking to different AI to take some decisions, and it will have like an logic over the decision logic. You can say like if the data matches, this is what it want to do. If the anomaly detected, proceed with the notification or some do some recovery. So those kind of things it do. Next is like a notifications and logging and feedback and calendar integrations. I'm keeping it as an option. Then compared to coming to the next steps, I'll explain you what we are going to do. So this is how you can build your own models or like in because if you want to keep your data secure and if you want to build your own health system based on your variable devices, yes, you can still do it by using this kind of AI tools. Okay. So this is about that workflow. I actually created a workflow, but I didn't have a system to show you over here. So this way it actually works. So the architecture of mainly of the system is like on a given schedule trigger. I'm having a schedule trigger that is expected to run every day 5 o'clock in the morning. So end of the day, I told you right, agent is having a workflow and the workflow is having an LLM into it, which can going to do all the operations instead of here. If you are not doing, if workflow is not going to do it, then you are end up doing each and every step of this, right? So as part of it workflow on step one, it is going to, so from your smartwatch, which is being kept over here, right? That is going to do a continuous feed of your data over the night or like in over the day to back into your data cloud, right? That is where your data has been actually living. If it has been private, you can keep the data, private cloud data back to you. And then the model comes up when this agent every 5 o'clock, every 7 in the morning, it gets triggered and start devising a workflow. It will go do the data collection from your data cloud to watch your sleep patterns or like any data, anything that it want to do, right? For example, it can go collect the data and it will go and talk to the Python components or like in Java components, whatever it is. There's a protocol how it want to talk, right? And go and talks to the protocol, and it used to detect anomalies, right? Then it detects anomalies, anything, any data that it want, right? Any actions that it want to take, it will go and talk with Python modules or Java modules. And then it will do once again data collection by doing your personalized calendar, right? It can talk to your personalized calendar and find your free time, right? And finally, it can do a notification service. All these are like a step-by-step process. That's what I do. And finally, give a notification to user. Like one such application-wise, how this workflows can be achieved, right? Calendar hour scheduling, right? In this calendar hour scheduling, right? Based on it analyzes your personal calendar, it analyzes your sleep patterns, and we know like everyone has been busy in doing different things in your life. And if you really want to find a scheduler, if you really want to find where you want to really do an exercise or like where you really want to do an workout, this workflow can help for you. It will check your calendar, it will check your data at a night, and then it will come and tell you, yeah, you have been slept only for 5 hours in a day, and you have been expected to do some workout today. Since your sleep is very less, I'm finding half an hour time schedule in your calendar by accessing your calendar, and I'm scheduling a workout time for you. That's what it do. Based on your sleeping patterns, based on your free time on your personalized calendar, you can able to schedule a workout time for you. Provided we need to be very much good enough in listening to the AI system and act accordingly. So that's what we need to do, right? And health-based workout planning, right? It is not about only one data, like sleep monitoring. It can able to cover lot of other data. It can able to cover lot of other data. It can be able to measure your SpO2. It can be able to measure your health heart rate. It can able to measure your like in different things that is been collected from data. Based on that, it is going to tell you in the last 24 hours, your health data looks like this. Based on that, I'm finding a schedule for you on your calendar based on your free time. And I'm also recommending you to go and do this kind of exercise because this kind of exercises are being recommended based on your health pattern that has been received in the last 24 hours. That is also very important. That thing also can be scheduled and can be achieved when you're creating a workflow, right? Real-time workout optimization monitors live data during the workouts. You know, right? The famous actor, right? The famous actor who has been passed away during the corona time, famous Canadian actor, right? He has been passed out when he has been doing exercise in the gym. Did you ever believe? It is because there is no real-time monitoring. This kind of things can be avoided. Because if you've been continuously monitoring your data, if your data has been continuously getting feed, your AI agent has been continuously running and monitoring you, it can tell you like some of your parameters getting bad, it will immediately going to warn back on your watch or back on your phone telling that your health is getting bad, don't continue on your operation or don't continue on your workouts. This kind of systems can save his life, who knows? So that time real workout monitoring also can be very much helpful. And the emergency call system, right? Suppose you are going in a road, you have been just got fainted and your phone has been locked. How anyone can be notified back to your phone? Your emergency call system, which has been continuous monitoring, can be done, can do that for you, right? So this is a way you can build your own workflow, you can build your own build systems if you want to keep the data private, right? So this is where this is where you can achieve things and basically taking data from your wearable devices. Okay, so let me jump into the challenges. And what has been very much challenging for us to build this kind of systems, right? So data privacy and security, that has been very much big challenge when you've been in the case of an open world, right? Cyber attacks, data breaches, right? The data when it's been getting transferred from your wearable devices to the cloud or cloud back into your like processing unit, right? Any person can inject their data into it that can do one false analysis, right? By that way, it will create a panic. That is also a problem, right? So to overcome all these things, you need to take up with the studies like regulations like GDPR, CCPA regulations that you need to take it, right? And then algorithmic robustness, right? As I told you, LLMs comes with more algorithm. LLM comes with like different kinds of algorithms, and it also like the amount of data feed that you have been putting vast and then diversified data is also very, very important, right? So that's where like how much of sorry, we are seeing some noise. Can you please go on mute? Yeah, thank you. Okay, so algorithm robustness is also very important. The amount of data that is feeding to learn your LLM to make the predictive analysis is being, it should be vast, it should be diversified. That is also very, very important. And the data quality issues. If there is too much noisy data when the data gets collected, it is going to be that sample of data is going to be get wasted. So it will be lead to a misleading health insights. That is will be also a problem. So, and regulatory and clinical validations, I told you, right? It is very difficult for a doctor to believe the data unless otherwise it has been regulated and it has been clinically approved. Only then these data are really going to make sense. User dependence and misinterpretation. Users may overlay on AI insights, right? Some people might be overthink, right? Unwanted anxiety. People by seeing, right? What about this? Like people have the monitoring systems in their hand, telling that, like, yeah, I'm seeing my SpO2 level very less. Then immediately they'll go to some medical stores. It has been very common in India, right? We go to the medical stores and we tell, like, yeah, I'm seeing some bad data. Can you give the medicals some medicine for it? Yes, medical store owner, it's end of the day, it's money for them. Surely they're going to use some medicine, which has been kind of the data, right? What we really mean is, right, the data are there, it can able to like misinterruption by the users. That is also a very, very difficult thing, which can really which can really cause your health down, right? So that also we need to be, we should not over enter. Technology to be used to its technology to be used to its limit. It can be used to its most, that will be very, very difficult, right? So integration with healthcare systems, there are many old systems, whether it can be AI adaptable. So those are some things which will be very challenges for us to make it to integrate and work with the systems, and accessibility and usability, right? So we people of modern ages can able to manage and work with the system, but that is it's a not a but that is not a real case in the case of old people, right? So where they have been not aware of all these systems, right? So those are all some challenges. Additionally, I want to touch on some technical challenges. See, when I was talking about the sensors. High quality sensors is very, very important. High quality sensors comes with like own cost. So that is there. And another thing is like the expectation is, right, you want to wear your devices always with you, right? And that point where you have been not wearing the devices, the data need to be forecasted. The forecasted data for the time that has been missing can't be accurate as well. So it is necessarily very, very important. So all these kind of technical challenges, like the battery life, like if the battery life of a device is that what has been you're using, so that is also very important. So all this will be kind of some technical challenges that we might face when you've been started using the system back into the systems, right? So coming back, so data and privacy, right? So this is, I already talked about like how important the data is. Like data is the money in the modern day, right? So the data is very, very important, and it is essential the data is in the correct form or like without any noise or be a fault in it. That is very, very important because it is all about medical systems, right? So encryption basics protects data from covering it from more secure format. So once you encrypt the data, it takes long time in the wire, or it takes like more battery as well to decrypt the data. So considerably more security means like more battery, more battery power, and like more data on the wire over the transmit. All those things really comes into the picture, but data security and privacy is utmost important when compared to this two. And regulatory compliance, I had put up slides on like what is GDPR and CCPA. If needed, you can go through it. I'm not going to get into that in detail because GDPR is about US standard and CCPA is about an US standard, talking about how the devices has to be built when you've been building a wearable devices. And data breaches, which has been become a very big problem. And similarly, like user awareness, educating user with security practices is very, very important. Security systems, if you have been not using your devices, or like if you have been not using your devices like in personal devices, right, properly, it will be a big problem. Additional to that, if you have been wearing a wearable devices, for example, the watch, whatever that you have been wearing, like smartwatches, ensure that it's been, when if it is under any data monitoring, ensure that it has been only you who always wears that watch. Don't share that watch back with your family because it can misinterpret the data, or like the data which has been going to feed back into your system is going to be like a different data that is going to corrupt your entire history as well, right? Because suddenly, if you have been known as being BP person for the past 6 months, here you have been wearing a watch, and if you have been giving that watch to your kid, and then the watch, if the kid is going to wear that watch for next 10 or 12 days, right? The data what has been collected for 3 days, it will become like an negate telling that you don't have a BP anymore. That's where it will enter. So personal devices like phones or especially the smart device watches, which has been under monitoring, health monitoring, right? Essentially, it should not be shared. That is also very, very important. And this is about regulatory compliance. I told you like left is the European standard, CCPA is an American standard. We can go through it if you've been really interested. And why it is really matters for wearables, and that's what I've covered there. It is wearables quite highly sensitive health data continuously. Misuse like an unauthorized access can lead to the privacy violations and legal consequences. Yeah, if you find that medical data has been went on a thread, and if you're able to find out who had been done the thread, surely like there will be a big consequence for that, legal consequence, right? Compliances ensure that the compliance, whatever the GDPR and CCPA compliance ensures that user trust, data security, and legal protection for developers and providers. Okay, so that's why this compliance comes into the picture. And finally, little bit on future trends, the way it has been getting developed, where it will go. It is as per my future predictability. It can be different also. So AI health coaches are sometimes back. We can go to see an AI doctor, virtual assistants for a personal health care. Systems can be mature enough to be able to tell you like it won't be diagnosed, but it can tell you right how to prevent the things, right? Initially. That's we call it as an AI doctor. Nanotech sensors. Today sensors have been day by day sensor size is coming down. And it's also like amount of power that uses to run that sensors also getting reduced day by day. So it means that we will get into the nanotechnology based sensors very soon. So integration with devices, enhancing devices to integrate with a lot of health systems so that we can see that a lot of medical systems can be used with the lot of with the AI capability, right? AI compatibility, right? So data privacy concerns, that is once again a big challenge. Some way data privacy will increase, and so day by day going, right? There will be a lot of technical compliance will comes into the picture, and many people who have been generating devices, they bring in strong encryptions over into a system, and they will adapt to the whatever the systems regulations, whatever they want to follow. Based on that regulations, they are going to develop the product. And then I'm into my final slides on summary and conclusion. So summary, we went through like what's wearable technology and what it does. And then like we talked about how AI techniques I'm going to bring into the wearable technologies and how we're going to convert the data collected from the wearable technologies back into an actionable or like in predictive data. And I also talked through workflow automation tools if you want to build your own systems or how the systems are actually built back into systems. So that's what I covered. And then I talked about RAG, AI agents. So if you've been really interested on having some hands-on, just try out those things. That will be really helpful for you if you have to have some hands-on. Yes, those are systems basically I use this to build my AI things back into my work. So that will be very much easier. And then about the regulations, about the wearable data regulations. Okay, so together, these technologies give us a path to create smarter, safer, and more personalized healthcare experience. Right, that's what's going to. But one thing that I need to quote before closing this is like building secure AI application for health systems, very, very sensitive data. Any data that can mislead can create a panic, right? If your sensors has been down and if it is going to report that you've been having a BP, abnormal BP, surely first thing before you will be get panic and you will be start having actions, right? So building a very accurate and health system is very, very sensitive because it will touch base each and every individual humans. So building that system has been very, very important. And it is everyone's responsibility to build it is everyone's responsibility to build and run the health system very safely. That is what very, very important, right? So that's where I'm winding up my sessions. So now I'm opening up for any questions if there is any. Sorry if I overboard the time.
Sir, questions available in chat box, sir.
Okay.
Participants are kindly informed that the feedback form or the feedback link has been posted in the chat box. We request you to take a few moments to provide your valuable feedback as your suggestions play a pivotal role in enhancing the quality of the future programs. I repeat, participants are kindly informed that the feedback form link has been posted in the chat box. We are requesting you to fill the feedback form as soon as possible as your suggestions play a pivotal role in enhancing the quality of the future programs.
Okay. Let me go to the question and then I'll reply back in the chat.
Okay, sir.
Yeah. Thanks everyone for the timing. And then, yeah, it's been 1.5 hour session. So, and that to this afternoon section. Thanks for being there. Yeah. Thanks everyone.
I repeat, participants are kindly informed that the feedback form link has been posted in the chat box. We request you to take a few minutes to provide your valuable feedback as your suggestions play a pivotal role in enhancing the quality of future programs. Thank you very much, sir, for your profound and thought provoking address. Your discourse on evolving dynamics of technology and its integration with healthcare systems has both insightful and inspiring. The clarity and depth which you articulated the importance of innovation driven progress have undoubtedly broadened our perspective. We deeply appreciate your graciousness, presence, and the wisdom you have shared with us today. Thank you so much, sir. Moving forward, I now invite Mrs. S. Indumati ma'am, Assistant Professor of Artificial Intelligence and Data Science Department, Mahindra College of Engineering, Salem, and the co-coordinator of Atal FDP to introduce our second distinguished resource person, Engineer M. Nagarajan, sir.
It gives me immense pleasure and pride to introduce today's chief guest, Mr. Nagaraj Mohantakumar, a IT professional with over a decade of experience in cutting-edge software development. Mr. Nagaraj brings with him more than 10 years of expertise in the world of .NET development, Microsoft Azure, and cloud technologies, and served as a technology lead at HCL Technologies and currently working in Senior Application Developer UPS Technologies, Chennai. Throughout his career, he has played pivotal roles in top-tier IT organizations like Cognizant, Infosys, L&Ds, contributing to innovative projects across sectors like law, banking, and hospitality. He holds a bachelor degree in electronics and communication engineering and is known for his in-depth knowledge of programming languages like C Sharp, ASP.NET, Angular, and SQL Server, and for his cloud-based work involving Azure Functions, Cosmos DB, and microservices. His contributions extend beyond coding. He has been a mentor, innovator, and award-winning team player, receiving accolades such as the Best Team Player Award at LexisNexis and multiple client appreciations for the performance optimization. What stands out about Mr. Nagaraj is not just his technical brilliance, but his ability to lead teams, support innovation, and adapt to emerging technologies, all while staying grounded, focused, and humble. Today, we are privileged to have such a dynamic personality and among us, someone who truly exemplifies the spirit of continuous learning and technical leadership. Let us all extend a warm welcome to our chief guest, Mr. Nagarajan sir. Welcome you, sir.
Thank you, ma'am.
Thank you, ma'am. With great anticipation, I now invite Engineer M. Nagarajan sir to deliver his address.
Yeah, thank you. So myself, Nagaraj. So I am currently working in UPS Technologies. I have 12 years of experience in software field. So I also work across various domains and technologies. So over the years, I have developed a strong expertise in software development, so project management and delivering quality solutions. So this was short about me. So shall we start this section now?
Yes, sir.
Yeah, thank you. So I will share my screen. So you able to see my screen?
Yes, sir.
Yeah, thank you. So today we are going to discuss about the natural language processing in clinical data management with the support of AI. So yeah, so today agenda was clinical data management. So the basics of NLP. The NLP means natural language processing. The applications which was in healthcare. So the technique and the architectures which was grooming in NLP. So the challenges were and the ethics what we are facing in natural language processing. So and what are the future trends in natural language processing. So this was the agenda overview for the today's session. So yeah, first, what is clinical data management? So the clinical data management is processing of collecting and cleaning the data gathered from the clinical trials and the patient interactions. So the primary objective is to ensure the data accuracy and the consistency. So actually the data types, the clinical data types was categorized into two types: structured data and unstructured data. The structured data is easily organized and analyzed, while it comes to the unstructured data, which is in text format or in image format. So we need to gather the data from that those formats. So this was the two types in clinical data. So few types of clinical data was structural data and semi-structural data. So the structured data is nothing but the clinical data refers to the information that is organized in the predefined format, so which is making easy to enter, search and analyze using computers. So the structured data is predefined fields in table format or in database formats. So easily searchable and computable. So while come to the semi-structured data, for examples of structured data was in for test reports we have WBC counts, the cholesterol levels and the blood counts. So these informations will feed into the table structures and we will get the information from that. So this is already in structured format. So while comes into the semi-structured data, right? In semi-structured data, the information does not fit nearly into the relational database or table format. So it is in a JSON format or XML format in some other format. The schema also not defined. So it is in free text format, but we need to gather the information from the XML format or JSON information. So this is semi-structured data. So the data management. So data management in clinical data refers to the systematic collections, storage, processing, and validation, sharing and protection of health-related data to ensure its quality, security, and usability and compliance. So the next one is regulatory standards. So we need to maintain some regulatory rights. So some laws we need to maintain when we are fetching the data from the uh, reports. So we need to maintain the privacy of the users' information like that. We need to follow some regulatory to maintain the data. So this was comes into the regulatory standards. So these are the types of clinical data. So the text impact in clinical data. So how we are gathering the data from the text. So first one is medical notes. The medical notes that which will detailing the patient's histories and observation. The second one is pathology reports. Summarize the lab findings and the diagnosis. The third one is clinical trial narrative. So it was the research kind of things. So based on some client issues, the clinical trials we will gather and it was reported in the text format. The final one is social determinants, identify the factors affecting the health disparities. Okay, so this was about clinical data. So why NLP is needed in clinical data? So over 80% of healthcare data is unstructured. So if it is structured, then it is no issues. We can gather the information from the structured data and we can optimize. We can build the system. So, but most of the 80% of the healthcare system is non-structured, unstructured. So we use natural language processing technique to automate the extractions and from the extraction of the data, we need to classify that and summarize that. So what it sends, which automatically ends with enhance the efficiency and the accuracy. So we have the clinical data management with more accurate and efficiency with the help of natural language processing technique. So in NLP in healthcare, currently in healthcare, what are the NLP techniques is available? That one is tokenization. So tokenization is nothing but breaking down the text into manageable units. So for example, in the text, the report text or summary report, we can extract the data and we can break down the text into the manageable units. So we will filter the data. So and again, the text classification. While filtering the data, we can classify those data which comes under which category like that. The third one is named entity recognition. So identify and classify using the key element in the mapping table. So for example, the system has some mapping tables, predefined vocabularies and all. So based on that mapping technique, we can classify those key elements. The final one is knowledge extraction. So the knowledge extraction is nothing but deriving the meaningful insight from the unstructured data. So that means we are extracting the actual diagnostic of the particular patient details from the unstructured data like JSON or XML. We can derive those information. So that is called knowledge extraction. So what are the fundamentals for natural language processing? So understanding the NLP, language models, applications of NLP, and the futures of NLP. These are the main fundamentals to understand the natural language processing. So what is understanding the natural language processing? The basics we need to understand what is natural language processing. So natural language processing enables the machine to understand the human language. It's about making the sense of what a person says or right. So that means in the report, the doctor reports, we need to understand what they are conveying it. So how the system will understand that. So that is that we need to understand the basics of natural language processing. So the language models. So what kind of language? The medical language. So also the other the medical details. Those language models also we need to feed in the system. So it will automatically
இப்ப
understood those things.
feedback link அனுப்பிட்டாங்களா?
The third one is applications of NLP. So not only in healthcare, the NLP is not only used in healthcare, it is also used in various techniques. Because this NLP is nothing but extracting the information from the free text or unstructured data. So it is also used in the various domain as well. So the futures of NLP, so which will evolve in the landscape and in innovations. So okay. Again, what is NLP? So we saw about NLP uses in clinical data processing. So basically, what is NLP? The NLP enables the computer to understand and respond to human language. Basically, that is the natural language processing. So it actually encompasses two things: natural language understanding, and another one is natural language generations. So the natural language understanding is nothing but it is focused on the complementing meaning. So from the human language, it will understanding what was the meaning of the particular data in the particular unstructured data. So in natural language generation, which is about producing the coherent text. So from the human language, it will convert it into the text format. So that was natural language generation. So that means it's basically energy is a process of generating the human language from structured or unstructured data. It is about creating these texts that sound natural. So this is called NLG. Okay. So together this NLG and NLU, this component enhance the machine communications and the interaction in various applications. So these are the NLP workflow. First one is data acquisition. First we are extracting the data. Then pre-processing. We are cleaning and preparing the data for model training. So after the pre-processing the data, the third one is model training. Training the algorithm. So the final one is evaluations. The key NLP tech task was tokenization. The split the text into individual words or tokens. From first, we'll extract the data from the unstructured format. Then it was lemmatization. Convert the word into their base or root form. Then third one is part of speech. So we'll tag that with the relevant. Identify the part of speech for each token. The fourth one is named entity recognition. One second. Named entity recognition. The fifth one is relational extraction, and the final one was sentimental analysis. So these are the natural language processing. These are the tasks we need to ensure to extract the data, and we will prepare the data from the unstructured data. So the natural language processing in medicines. So in medicines fields, so what are the things? Domain vocabulary. So which was related to the healthcare things. So what are the vocabularies we are using in? So and the abbreviations, ontologies, and the standard course. So these are the natural language processing which are used in medicine field. Okay. So the traditional versus deep learning in NLP. So the natural language processing in medicines has evolved significantly, which with the traditional method being fundamental yet limited. So actually, this was three techniques. We are categorized into three main approaches. First one is rule-based system. The second one is statistical method. The third one is neural approaches. So the rule-based method is meta mapping kind of things. We will map the record we are mapping table. We are extracting the data based on that mapping table. The statistical method is techniques such as using HMM and the CRF utilize the statistical relationship within the language data to improve the performance. So which is completely better than the rule-based system. Neural approaches is like BR, which is using the BRT. BRT is nothing but bidirectional. It will extract the data in two directional. So then from that it will processing the things. So NLP tools in healthcare. So these are so whatever we are saw here, right? So rule-based system and statistics method. So these are some tools which was used in NLP. So one was CTEX and the another one was MetaPap and the third one is CLAMP. Yeah. So the final one, the next one was regulatory standards for NLP. So what are the regulatory? So regulatory, I already said we need to follow some standards to prepare the data. So the first one is HIPAA compliance. So ensuring the privacy and the security of the health information. The second one was GDPR regulation. So which will regulating the data protection and the privacy in the EU. The third one is HL7 FHIR standards, which will facilitate the interoperability of health information. Okay. So the next one was data pre-processing and annotations. Annotation is a process of labeling the data, such as text, images, or audio, within the metadata that provide the meaning or structure. It is essential for training, validating, and evaluating the machine learning and the natural language processing models. In simple terms, annotations is nothing but adding human understanding meaning to raw data for machines to learn from. So this is was about annotation. So what are the challenges is in clinical text? So this is we need to identify the abbreviations from the free text data. So differentiate the medical terms from slang. So the typo on the short term. Sometimes we are in unstructured data. It is in short form. So we need to impact on data accuracy interpretations. The third one is mixed structures. Sometimes it was combination of structured and the unstructured data. The fourth one is contextual understanding. So identifying the nonsense in clinical language. So this was the challenges in clinical data. Yeah. So the next one is text pre-processing steps. So de-identifications, tokenization, normalization, and enhanced accuracy. So these are the pre-processing steps in text. So next one is clinical vocabulary normalization. So clinical vocabulary normalization is process of mapping the non-standard variables found in clinical data to standard medical terminologies or codes. So this is clinical vocabulary normalization. So for annotating the EHR notes, we are using this technique, highlighting the symptoms. So on the medication documentation, diagnosis recording, standard terminology, and the final one is clear communication. So highlighting symptom is nothing but mark specific symptoms clearly. So the symptoms which was in the text unstructured data, we need to mark specific symptoms very clearly. So medication documentation, record all the medication prescribed in the document. So diagnosis recording ensure the accurate diagnosis which was logged in the unstructured data. So the next one, standard terminology, use constant clinical vocabulary. So clear communication, facilitate better healthcare clarity. So these techniques we need to follow in to annotating the information from the EHR notes. Yeah. So annotation tools overview. So as I already said, broad a browser-based tool for text annotation, light tag, collaboration tool for annotation tag, Inception, schematic annotation tool that integrate with AI. So next we are going to see the natural language processing technique overviews. So in NER in healthcare. So NER stands for named entity recognition. So it is also a natural language processing task that involves automatically identify and classify the key clinical concept in unstructured medical tests such as disease, symptoms, medications, procedures, lab values, and more. In simple, how we can say means finding important medical terms in clinical tests and labeling them with their types. So this is NER. So for that we need to follow these steps: identity the diseases, detect the drugs, and recognize the procedures and classify the labs. So the next one is clinical relational extractions. How we are extract the data from the unstructured data which was related to the clinical data. So first we need to linking that symptoms. If you are extracting the data from the unstructured report, so we need to link which symptoms the current data which you are retrieving. So connect symptoms to relevant diagnosis. So similarly, link diagnosis. Establish the connections to identify the disease. Third one is linking drug. So we need to link the drugs. Which kind of drugs we can uh, suggest for this. So the fourth one is linking dosage, detailed so how much dosage of drugs we can use for this particular kind of symptoms. The final one is enhancing the patient care, so which will improve the treatment effectiveness through accurate linking. So this was about the clinical relation extractions. Yeah. So next we can see about the negotiation detection. So this is nothing but is a process of identifying whether a clinical concept is negated in text or not. For example, in if the doctor is asking whether he have a history of diabetes, so the patient was saying no. So from the unstructured data we can't receive the data as the patients have diabetics like that. So we have a negotiation detection also in the system which will understand the understanding this data. From that it will negotiate and will update the system. So this was about the negotiation detection. So in simple, negotiation detection tell the system whether a condition is actually present or the doctor is saying it's not. So the next one is temporal info extraction. So the temporal info extraction is a process of identifying, interpreting, and structuring the time-related information from clinical tests. This includes recognized dates, duration, frequencies, timelines, and the temporal relationships. So in simple, uh, when, for how long, in what order, reading the symptoms. For example, if you have your symptoms, how long the patients was affected, so what are the symptom, what are the diagnosis they have taken place. So these all those informations which was falls under the temporal info extraction. This kind of extraction we call it as temporal info extraction. So first one is identify the key events. Second one, establish the event sequence, analyze the temporal relations, enhance the clinical understanding, support clinical decision, finally integrate with NLP system, natural language processing system. Cohort identification. So it's a process of selecting a specific group of persons from the clinical data based on their characteristic. So such as the characteristics such as diagnosis or treatment outcomes, whatever. It is essential for clinical research, quality improvement, population health. So and it is also help in the AI model development. So this is what about cohort identification. So the process built upon the insight gained from temporal info extraction and facilitate more targeted trials. So automated patient identification, integration with the clinical events, streamlined recruitment process. These are the three techniques we are following in cohort identification. So de-identification process. So after we are extracting data from the unstructured data, right? So we need to remove the privacy information. So for example, patient's name removal, address removal, ID eliminations. So other anonymization we need to remove. So and also the patient privacy, all the privacy information as part of the identification process, we are remove from the user's data. So yeah, the next one is clinical note summary. So this clinical note summary. So identify the key points what we are extracting from the unstructured data, categorize the information, streamline the data. So eliminate the duplicate data and facilitate quick reviews. So finally we have your notes which are conscious for easy understanding. So these are the overall summary about the clinical notes. Yeah. The next one is coding assistance. So the CPT Core Assistant is one of the revolutionary tools in the healthcare system, enhancing the efficiency in clinical documentation. So which will improve the efficiency in the clinical documentation. So it leverages the advanced algorithms. So usually the NLP systems and all using the algorithm to extract the information from the unstructured data. So one of the algorithm was streamline coding process by automatically assigning the accurate codes based on the clinical notes. It minimize the human errors and also the time also. It also save the time as well. So second technique was improve the data consistency. This automated approach ensures that coding adheres to the standardized guidelines across all records. The third one is facilitate compliance. So the automated CPT code assignment aids in ensuring that healthcare provide com- completely with regulatory requirement, reducing the risk of audit and the penalties. So this is about the coding assistance. So which is the so foundation by ensuring that essential data is accurately translated into standardized code. Yeah. The next one is medication overview. Yeah, medication overview is a summary of the patient's medications, which including the current, past, and the prescribed drugs as well, along with the detailed dosages and the frequencies and the durations. All the information we are gathered. It play a vital role in clinical decision making, medication safety, and care coordination. Predictive modeling. So this will the predictive modeling is categorized in three: the risk assessment. So the utilize the discharge summaries to identify the potential readiness of the risk, the data integration, and the final one is clinical implications. Yeah. The next topic was architectures and the models. Yeah. So in architecture and also the rule-based NLP system. So this was the base for system in NLP. So the rule-based system is nothing but the extracting the data based on the rule. So for example, if the condition is met, then we can map to these things. Otherwise, we can map to other one. So it is all the extraction is based on the rule. So that's why we are calling as rule-based NLP system. This again rely on the predefined rules and the grammatical structures, making them effective in specialized field. So, however, there was low adaptability. That means there was hinder performance in dynamic and the evolving language context, limited the application in more general and various scenarios. So, it was again the limitation for usage because it was working only for the standard rules. So, that is the reason. So, okay. So, next one was machine learning approaches. So the machine learning approaches in NLP uses the algorithm that learn pattern from data to automatically perform tasks like classifications, extractions, predictions without explicit manual rules. So this approach uses the logistic regression, support vector machine, conditional random fields, adaptability, adaptability, adaptability to data, explainability challenges. So we can see this detail in next slide. So logistic regressions. So logistic regression is a supervised machine learning algorithm used for classification tasks, particularly when the outcome is binary. Okay. So despite its name, its classification method model, not regression. For example, the output was in the binary model. So for example, if you have a disease or no disease, like that. So this is the algorithm. The algorithm follow these steps. Yeah. Next one is support vector machine. So it is also the learning algorithm used primarily for classification tasks. It works by finding the best hyperplans that separate data points of different classes with the maximum margin. So the SVM algorithm involves several key steps: mapping data points. So this mapping data point is mapped to future space. Often use the kernel trick to handle the non-linear separation. So the next one is finding the hyperplan. The goal is to identify the hyperplan represented by the equations, which effectively separate the classes with the largest margin. Next, optimization problem. This optimization task here is to minimize and subject to the constraints that each training sample satisfies. Utilizing, utilizing support vector, and the final one is decision making for new data. For any new data point, the decision is made using the equations determine to which classes the point was belonging. So it solves depends upon the algorithms we are following. Yeah. The next technique was conditional random fields. So the conditional random fields are the type of probabilistic model. So which was following the probabilistic model used in the structured prediction task, where the output is sequence or structure set of labels rather than a single label. So it was rather than a single label, it was a sequence of structured set of labels. They are widely used in natural language processing and for tasks like named entity recognition, especially in clinical and biomedical ethics. We are using these conditional random fields. So these conditional random fields, right? So which was following the algorithm primarily follow the below steps: the featured functional definitions, probability definitions, training and inference. So these three steps there it is following. So future function definition define future functions that rely on label and observed data with their respective parameters. So the probability definition for a given input sequence uh, X and the label sequence Y, the conditional probability is formulated. So this involves a normalized factor. That means the exponential sum of the future functional weighted by their parameter. Yeah. The third one is training and inference. The training is conducted by the maximizing the likelihood of this through sequence, typically employing the methods like gradient ascent on negative log likelihood. Okay. Actually, the CRF enhances the model of dependencies with the data, making them suitable for complex structured prediction tasks, which is closely following the principles of support vector machines. Yeah, neural networks in NLP. So the neural network is recurrent the neural request, long short-term memory, and get a recurrent unit. So recurrent neural network are designed for processing the sequence. So long short-term memory helps overcome the vanishing the gradient issues. The GRU provide a simplified alternatives to the long short-term memory. So this is the alternative for long short-term memory. GRU is yeah. The the next one is transformers in healthcare. So how we are transforming the data while we are extracting from the unstructured data. So the first technique is BERT, the bidirectional encoder representation from transformers. So what is BERT? The BERT read the sentence in both forward and backward at the same time. So it understand the meaning of the words in context better than older models and all. So this is the advantage of BERT. So the BioBirth is nothing but the birth variant from the biomedical test. For the biomedical test, we will follow the same pattern. So that we call it as BioBirth. So another one is clinical birth, adapter for clinical settings, BlueBirth, optimized for clinical NLP task. So applications used for generating the patient reports, the future prospect potential for deeper healthcare insights. So the transformer is used to extract the data in using the BERT technique. Yeah. So clinical NLP transfer learning. So clinical NLP transfer learning is nothing but the transfer learning in clinical NLP refers to the approach of reusing the knowledge form from pre-trained models and fine-tuning them on specific clinical task. So this was about the clinical NLP transfer learning. So yeah. So hybrid approaches. So the hybrid approaches is in NLP combines the rule-based method and the machine learning. So we have saw about the rule-based method and the machine learning in previous slides, which the hybrid approach is a combination of these two approaches. So this technique is improve the accuracy of the data. So combining rules and the learning. So integrate rules with the deep learning techniques. So improved accuracy, how enhance the precision in clinical language tags. Handling complexity, manage complex critical terminology effectively. So the next one, flexibility in application. Adapt to different clinical contents. So we have different clinical contents, right? The flexibility in adapting that. Real world implementation. So which will help to connect with the theoretical as well as the application side as well. Yeah. Yeah. The next we are going to see about the clinical birth and MIC3. So this is dataset overview, exploring the MIC data source. Then we are modeling that one. That means detail on clinical birth application. The final one is prediction result, insight from ICU mortality predictions. So this technique and all used to extract the data from the unstructured data. Yeah. So real world applications. So these applications of clinical birth and MMIC data instance, which was beyond the research. So and also real world implementation, including the predicting the patient outcomes in ICUs, aiding clinical decision making, and enhancing electronic health record system. Okay. What in NLP in clinical trials? So the natural language processing play a critical role in screening the patients from pre-tested data during the clinical trials. So is in simple how we are means NLP helps automate and accelerate the many manual tasks in clinical trials by extracting the important medical info from pre-text documentation like EHR, trial protocols, and eligibility criteria. So this process typically involves data extractions, patient's eligibility, and the reduction of bias. So data extraction is identifying and extracting the relevant characteristic from the medical records and the clinical notes. So patient's eligibility determines if the patients meet the specific criteria or not. The reduction of bias, minimizing human errors and biases during the screening process, ultimately leading to more reliable trial results. So the integration of NLP not only enhance the efficiency of the patient recruitment, but also support better decision making in the clinical environment. So it not only extracting the data from the system, it is also we will give the decision making in the clinical environment. So as we look ahead, we'll explore the implications and the challenges of implementing the NLP technology in clinical practice. So this is one, and the pharmacovigilance overview. So which helps monitor what happened to people after taking a drug. That means to catch and respond to side effects, allergies, or dangerous reactions. So especially after the drug is on market. So this report is based for that. So for that we need to data sources. We need data sources for the each drugs or for any patient's reports. So these reports from healthcare providers or patients, we can collect those information from them. The signal detection. The signal detection is nothing but identifying the patterns in drug events. So the risk assessment. What are the risks related to that drugs? The regulatory report. Submitting the findings to health authorities. So that was all about the regulatory reporting. And the final one is for patient safety. Ensuring ongoing monitor for drug safety. So for when the patient consuming that drugs, so it will be safety or not. So this report will help us to understand. Yeah. Next one is EHR data mining. So how we are mining the EHR data? So for that we first of all, what is EHR data mining? So which refers to process of extracting the actionable knowledge from electronic health records. So EHR stands for electronic health records. So to extract the actionable knowledge from that report records, we are using EHR data mining. So for that, we need to identify the influential factors, and then we need to integrate with the data source, and finally analyze the patient's outcomes, and drive the public health initiatives. It will help for public health initiatives. That means using insights for better policies like that. Yeah. Next one is population health insights. So population health insights. That means the data analytics, risk assessment, and the targeted intervention and the community engagement. So the data analytics means utilizing the data to identify the health trends. So what are the health insights we are received from the healthcare, right? Based on that, we can do some analytics. So what symptom is majorly affected in the world like that. So again the risk assessment. So the third one is targeted intervention, and the final one is community engagement. So this statistical data we can uh, retrieve from the extracting data. Yeah. Next one is radiology report mining. So radiology report mining is nothing but the NLP system technique is to analyze the radiology reports. That's we are calling it as radiology report. So for that we need to follow these 6 steps to extract those radiology report data. The first one is NLP application, which will utilize the NLP to extract the data, which use the NLP system to extract the data from the radiology report. Then one is data structuring. The data structuring technique organize the data from that means extracted data from the report, right? We are organizing that one. Then trend identification. That means finding the patterns in radiology report. Then risk prediction. Risk prediction means assessing the patient risk based on the images. That means based on the records we have received. Outcome enhancement, improving the patient care through insights. Final one is collaborative approach, engaging the stakeholder in data use. Yeah, this was about the future trends, voice to text integration. So using the automatic speech recognition ASR technique to translate the doctoral clinical spoken words into the digital text that can be stored and analyzed and used with healthcare workflows. Yeah, voice to text technology is a revolutionary clinical document by streamlining the data entry process. So, which this integration enhance the accuracy and they reduce the time spent on the administrative tasks. That means um, instead of we are extracting the data from the text report or the clinical notes or reports like that, instead of that we are converting the doctor discussion into the text format. So, use of that is to the data accuracy was improved. So, that was we are saying. So, improved accuracy, enhance the efficiency also enhanced, and the seamless workflow. So these three things we have achieved. So in addition to that, we will see about the AI applications in clinical practice. So, AI applications in clinical practice, the findings are the process of developing a new technique as a established standard of care use, the robust practice of peer-reviewed R&D, and can provide safeguard against the deceptive or poorly validated use of AI algorithms. The use of AI dynamics as replacement of the for established steps in medical standards of care will require more validation than the use of such diagnostic to provide supporting information that aids in decision. Recommendations. Support work to prepare AI results for the rigorous approval procedure needed for acceptance for clinical practice. Create testing and validation approaches for AI algorithm to evaluate performance of the algorithm under the conditions that differ from the training set. Yeah, the confluence of AI and smart device for monitoring health and diseases. The findings are revolutionary changes in health and the healthcare are already beginning in the use of smart device to monitor individual health. Many of these developments are taking place outside of the traditional diagnostic and the clinical settings. In the future, AI and the smart device will become increasingly interdependent, including in health-related fields. On one hand, AI will be used to power many health-related mobile monitoring devices and apps. On the other hand, mobile devices will create massive data set that, in theory, could open a new possibilities in the development of AI-based health and healthcare tools. Yeah, the recommendations are support the development of AI application that can enhance the performance of the new mobile monitoring device and apps. Develop data infrastructure to capture and integrate data generated from smart device to support AI application. Require that development includes approaches to ensure privacy and the transparency of the data use. Track development in foreign healthcare system, looking for useful technologies and also technologies failures. Yeah. The third one is create comprehensive training database of health data for AI tool development. For the findings are the availability of and the access to high quality data are critical in the development and the ultimate implementation of AI application in healthcare. The AI algorithm based on high quality training sets have already demonstrated performance for medical image analysis at the level of medical capability that is captured in their training data. AI algorithm cannot be expected to perform at the higher level than their training data, but should deliver the same standard of performance consistently for data within the training space. The goals for AI tools include accelerating the discovery of novel disease, correlation, and help match people to the best treatment based on their specific health, life experience, and generic profile. Definition and integration of the dataset required to develop such AI tools in a major challenges. Extreme care is needed in use electronic records as training set for AI, where output may be useless or misleading if the training set contains incorrect information or information with unexpected internal correlation. Techniques for learning from unlabeled data could be helpful in addressing the issue with using the data from the diverse set of core sources. Recommendations. Support the development of access to research data set or labels on unlabeled health data for the development of AI application in health. Support investigation into how to incentivize the sharing of health data and a new paradigm for data ownership. Support the assessment of AI algorithm trained with the data label at a level that significantly exceeded the standard assessment. For instance, the uses of output from the next stage of diagnostic. Support the research to characterize the trade-off between the data quality information content and the sample size, with the goal of enabling the quantitative prediction of the quantity, the quality of data needed to support the given AI application. Identify and develop strategies to fill important data gaps for health. Develop automated curation approach for broadly based data collections to format them for AI tools. Yeah, the fourth one is fill critical missing data gaps. So how to fill that gaps? The findings are AI application development require training data and will perform poorly when significant data streams are absent. While DNA is the blueprint for life, health outcomes are highly affected by environmental exposures and social behaviors. There is an imbalance in the effort to capture the drivers data needed for applications of AI technique to precision medicine, with information on environmental toxicology and exposure particularly suffering. The recommendation support ambiguous and creative collections of environmental exposure data, build toxic screening, start urban sensing and tracking programs, support the development of wearable device, support the development of the broad-based pattern sensing, develop the protocols and IT capabilities to collect and integrate the diverse data. Yeah, the fifth one. Embrace the crowd sounding movement to support AI development and data generation. The findings are the AI computations have already demonstrated their value in encouraging the creation of logic corpus of data for broad use and demonstrate the capability of AI in health when provided data that are curated into a well-labeled format. The recommendation support computation created to advance our understanding of the natural of health and healthcare data. Share the data in public forums to engage scientists to find the new discoveries that will benefit health. Yeah, next one. Understand the limitations of AI methods in health and healthcare application. What are the findings? There is a potential for the misinformation that could cause harm or impede the adoption of AI applications for health. Website, apps, and companies have already emerged that appear questionable based on the information available. Methods to ensure method to ensure transparency to disclose of large-scale computationally model and method into context of scalarity reproducibility we are just beginning to develop in the scientific community. Support the development of critical safeguards that are the essential to enable the adoption of AI for the public health, community health, and the healthcare delivery. Encourage development, adoption of the transfer process and policies to ensure the reproducibility for large-scale computational models. To guard against the proliferation of misinformation in the emergency field, support the engagement of the learned bodies to encourage and endorse best practice for the development of AI application in health. Yeah. Just an artificial intelligence where computers perform the tasks that are used assumed to require human intelligence is currently being discussed in nearly every domain of science and engineering. Major scientific computations like ImageNet, large-scale visual recognition, are providing evidence that the computers can achieve human-like competence in image recognition. The promise of AI is tightly coupled to the availability of the relevant data. In the health domain, there is an abundance of data. However, the quality of and accessibility to these resources remain a significant challenge in the United States. On the other hand, health data has privacy issues associated with it, making the collecting and sharing the health data particularly compared to other types of data. In addition, health data are quite to collect, for instance, in the case of longitudinal studies and clinical trials. At the same time, there is a wide private sector interest in AI in health data collection and applications are illustrated from the numerous data related to AI in health and healthcare. There have been a significant demonstration of the potential utility of artificial intelligence approaches based on deep learning for use in medical diagnostics. While continuing basic research on these matters is likely lead to further advantage, we recommend parallel focused work on creating rigorous testing and validating approaches. Advances in AI applications for medical imaging. In the following scenario sections, we will review the example in which application of deep learning have been demonstrated. With attention to quantitative understanding of characteristics of dataset, the problem definitions, the nature of the comparison standard used for the labeling they set. The two examples described are based on medical imaging and specifically diabetic retinopathy and dermatology. Detection of diabetic retinopathy. Second one is dermatological classification of skin cancer. Okay, what are the possibilities of data? Each of the examples, the access to high quality labeled data is significant barrier in the development and evolutions of AI algorithm for clinical decision making. The process of developing the training labels from the existing records requires skilled label reviews of patient chart to create meaningful labels. As a result of the time and the cost involved, many publicly accessible label sample sets are too small for the best training and testing of the AI algorithm. Data sets are that are labeled from the clinical may be a variable quality that limits the training efficiency as moving computational advances in the clinical practice. Computational methods are recognized as a special type of tool in medical practice, where they impact clinical practice are subject to different forms of regulations. AI-based tools represent a new set of opportunities, but lack the extensive basics of the experience and validating that is needed for acceptance into the formal medical practice. In this section, we are address the questions of how AI-based computational approaches could become sufficiently trusted to modify the protocols for diagnosis and treatment, enabling the improved outcomes of the lower the cost. We use the example of a new computational tool that require large-scale computation, but is based on the physical properties rather than a trained AI algorithm. The example illustrates the rigorous process of review and the development needed to validate a new technique. For clinical practice, it's also illustrates how important the demonstrations of the benefit of a new approach is to eventually uptake it's a clinical tool. Development and validation for clinical application. A private company, Outflow, led development of the FFR technology for a clinical use. In 2014, the company received the FDA approval to market the technology based on its demonstration of subsequent equivalent to the predictive device. In parallel, additional studies were underway to establish whether FFR is a feasible alternative to inversely coronary. Summary points for developing the clinical application. The FFR example illustrate the key issues for a new computational technology to enter into the practice. The technology should address a significant identified clinical need. The technology must perform at least as well as the existing standard approach. The subsequent clinical testing is needed to verify the performance of a new technology under the wide range of clinical situations in which it may be used. The new technology should provide improvement in patient outcomes, patient quality of the life, practically in use, reduce in medical system costs. Because the FFR technology is based on physical principles rather than the less understood correlations of AI. Its review and assumption process likely face less skepticism than a new AI assessment. At least as rigorous will be needed. Evolutions of the standard for AI in medical application. In the US, adoption of AI application for the clinical process will be regulated by a combination of Food and Drug Administration regulations and the clinical business models. For a non-clinical personal smart device, users are discussed in a following section. It will require public confidence and may or may not require regulations. In the example above, the adoption of the FFR computational tool requires clinical studies. This will also necessary for AI outcomes to be accepted as a definitive decision factor in the standard of care. Such a decision may need FDA regulation and a specific of what those requirements might be still evolving. Clinical trials and the regulations are only part of the story for adoption of AI application. In addition, clinicians or health professionals must be willing to incorporate this application into their workflows. The FFS examples of Section 2.2 and the AMS studies discussed in Chapter 3 point out the adoptions will depend on how well ML device and application fit within the existing system and the practice. However, even to support the development of the clinical trials and the assurance that the AI applications are legitimate, including for non-regulated applications, the technical soundness of the algorithm need to be confirmed. This point is addressed in more about that. Proliferation of device and app for data collecting and analysis. Smartphone and other small technologies are already in a primary platform for the adoption of the health and wellness through mobile apps and network device. These apps and device support the full spectrum from health issues sick. There is active research on the disease design and the testing of the usability of the app's device. Additionally, many of the health applications are being included in clinical trials. They are being used as a mechanism to collect information for the trial to evaluate the specific device and our app users. To evaluate these usefulness in combination with other health behavior, for example, this growth in the development of more serious health devices that could be used to monitor and communicate health status to a professionals has attracted the attention of the American Medical Association. An EMA survey related that 31% of physicians see the potential for digital tools to improve the patient care, and about half are attracted to digital tools because they believe they will improve current practice with respect to efficiency, patient safety, and improve diagnosability and the physician-patient relationship. The study goes on to point out that the adoption in liability data privacy assurance, ability to link the electronic health records, and the billing reimbursement. These same points reflect issues for the adoption of AI application. These are all promising direction for the development of applications of my health tools. The focus here is on the types of devices and apps that have been potential to benefit from AI application, either in their individual functions or when the data generated by the device can be integrated with other health information to support wellness versus sickness. Yeah, thank you. So if there is any questions, we'll continue. Thank you.
Good afternoon, everyone. Myself, Kishore. I continue this session. Clinical data management. Clinical data management involves the collection, cleaning, and management of data from clinical trials to ensure accuracy and compliance with regulatory standards. CDM primarily deals with structured data like lab values, vital signs, but significant portion of clinical data is unstructured, such as physician notes, discharge summaries, radiology and pathology reports, patient feedback, and social determinants of health data. Managing this unstructured data manually is time consuming and error prone. This is where NLP comes into play. What is NLP and why it's important in CDM? NLP is a branch of artificial intelligence and data enables machine to understand, interpret, and process human language. In healthcare, over 80% of clinical data is unstructured. Example, free text notes, which makes NLP critical for extracting meaningful insights. Benefits of using NLP in CDM. Automation of data extraction, reduction of manual efforts and errors, better regulatory compliance, improved clinical decision making. Key application of NLP in clinical data management. First, data extraction and structuring. NLP algorithms can extract critical clinical essence such as diagnose ICD codes, meditation and dosage, symptoms and adverse events. Example, from a physician note, patient diagnosed with type 2 diabetes and metformin 500 gram twice daily. Adverse event detection. Identifying mention of side effects in patient notes or clinical reports in curricle for pharmacy. NLP can flag potential adverse drugs reaction for further review. Third, clinical trial data monitoring. NLP can scan free text clinical trial reports and identify protocol critical automatically. Medical codes and compliance. NLP assists in mapping clinical notes to standard code system like ICD-10, SNOMED, CT, MedDraw. Sentiment and behaviors analysis. Analysis patient feedback or progress notes for early detection of mental health issues or treatment adherence. Fourth, techniques and tools in NLP for CDM. Techniques used. Techniciation, splitting sentence into words, name entity recognition, NER, identifying entities like drugs, diseases, symptoms, part of speech tagging, understanding context in a sentence, dependency parsing, understanding a relationship between words, sentiment analysis, determining tone of text, popular tools and frameworks. Apache C takes clinical text analysis and knowledge extraction system. MetaMap development by NLM for mapping biomedical text to UMLS. SPACY plus MedSpace SPACY. BERT based models. Clinical BERT, Bio BERT for context-rich text understanding. Challenges in implementing NLP in CDM. Data privacy and security. Compliance with HIPAA, GDPR. Data quality issues. Domains, specific language, integration with existing system, bias and interpretability. Future of NLP in clinical data management. AI-driven clinical decision support system, real-time insights from unstructured data. Integration with predictive analytics. Combine NLP with ML for risk stratification. Voice recognition. NLP automatic clinical documentation from voice notes. Generative AI summarizing length reports, creating structured case summaries automatically. Thank you.
A kind information, the feedback form link has been circulated in the chat box. Kindly take a moment to complete it, as your valuable suggestions will assist us in curating more impactful sessions in the future. I repeat, the feedback form link has now been shared in the chat box. Kindly take a moment to complete it, as your valuable suggestions will assist us in curating more impactful sessions in the future. So there's a question in the chat box. In what are all the ways we use AI medical image processing? How can we detect the anomalies?
Yeah, good question. AI in medical image processing is used for diseases detection and diagnosis like cancer, stroke, eye diseases, image segmentations, organs, tumors, and like image enhancement and reconstruction like noise reduction, super resolution, 3D reconstruction and visualization, planning, redynamics and future extraction, hidden patterns for personalized medicines, automated reports generated like AI assistants, redirect reports, and drugs development and trials like imaging biomarkers, mass screening like TB, cancers, high diseases in large pollution. Any other questions?
Okay, thank you, sir. I got it, sir. Thank you, sir. How can we detect the anomaly, sir?
Yeah. Can you repeat me?
How can we detect the anomaly, sir?
We detect anomalies by teaching AI what normal looks like, then flagging anything unusual in the medical image.
Okay, sir. Thank you.
I repeat again, the feedback form link has now been circulated in the chat box. Kindly take a moment to complete it as your valuable suggestions will assist us in curating more impactful sessions in the future. I repeat again, the feedback form link is in the chat box as well as the WhatsApp group. We request all the participants to kindly submit your feedback form as it holds immense significance in refining and enhancing such academic endeavors.
Shall I start?
Important note, the feedback form link has been now shared in the chat box as well as the WhatsApp group. Kindly take a moment to complete it as your valuable suggestions will assist us in curating more impactful sessions in the future. Now, I once again invite Mrs. Indumati ma'am, Department of Artificial Intelligence and Data Science, and also the co-coordinator of 6-day Atal FDP program, to introduce our third distinguished resource person, Dr. A. Gayatri ma'am.
Good evening, everyone. Dr. E. Gayatri, Assistant Professor, Grade 2, Department of Information Technology, School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. Let's welcome our Dr. A. Gayatri, ME PhD. Dr. Gayatri holds a PhD from Anna University, Chennai, which she completed in 2018 with a specialization in computer networks. She also earned a master degree in computer science from Anna University in 2006 with a distinction and a bachelor degree in computer science in 2003 with a first class. Dr. Gayatri has a collective experience of 13 years in both working and research. She has served as an assistant professor at Vellore Institute of Technology, Rajalakshmi Engineering College, and Sri Venkateshwara College of Engineering. Her PhD research focused on techniques for intrusion prevention and enhancing the performance in managed network engineering. The area in which her PhD was awarded is Information and Communication Engineering. Her subject specializations include network security, mobile computing, operating systems, software engineering, and the Internet of Things. Dr. Gayatri has also been a prolific researcher with numerous publications in international journals and as book chapters. Her work covers a wide range of topics, including security in managed energy efficient routing in wireless sensor networks and applications of machine learning in various fields, such as predicting liver disease. She has also contributed to publications on topics like a novel wearable therapeutic aid and smart active helmets. Please join me in welcoming you, Dr. Gayatri ma'am. Welcome, ma'am.
Thank you so much for the kind
Thank you,
introduction.
ma'am. It is my privilege to now invite Dr. A. Gayatri ma'am to share her message with us.
Yeah, thank you so much, ma'am. Is my screen sharing is visible?
Yes, ma'am.
Yes, ma'am. Shall we proceed?
Yes, ma'am.
Yeah, thank you so much for a kind invitation. So the given topic is for me is data security and privacy for AI driven in healthcare system. So basically, what do you mean by AI? Artificial intelligence is more significant. For what under what circumstance you can say that AI is more important? Say, for example, in this today world of science and technology, many new fields come into role of action, and many innovative thoughts are coming into role of play. So, artificial intelligence is very, very significant because it transforms how we can interact with the technology, how to solve the real-time problems, and how to take a quick decision. In this way, only AI plays a very important role. Say, for example, if AI impacts spans in industry, moreover, AI rocks in healthcare field, finance field, transportation field, and moreover, it is very useful for healthcare center. In healthcare, it plays a very, very important role such as robotic assistant surgery, and more in depth, it gives the advice for giving a virtual environment. And moreover, this AI also have a very proven records in entertainment also. So the key reason why I've chosen this AI is more significant means because of automation. So everything can be done in automation, and efficiency plays a very, very important role in order to enhance the productivity. At this situation, we are going to discuss, and in this particular point of in this particular session, we are going to introduce AI in base of healthcare industry. So now we are going to look into the introduction, terminology, history, advancement around the globe in health and public health, and conclusion. So basically, in this particular session, what are the main objective, what are the key points we are going to discuss in this data security privacy for AI driven in healthcare industry, healthcare system. So basically this AI is very much important in all kind of area. In specific, it is used for real-time monitoring. Real-time monitoring means in real time, humans won't be present. At the time, with the help of assisted gadget, we can able to monitor in a real way, stating that with the help of AI tools, we can able to interact with the live manner. And moreover, with the help of IoT device and medical sensor, we can able to track the patient health history, and we can able to detect in a real-time environment if any abnormality found in the patient health condition. So health condition can be tracked properly. If any abnormality is found, means automatically in the earlier stage itself, we can able to detect. In that way, AI plays a very key important role. The next thing is how to focus to enhance the clinical decision making. In this thing, AI plays a very, very important role in order to scrutinize the medical data, in order to support the doctors for accurate prediction, and you can able to give the very good recommendation which treatment supports for the particular disease, diagnose the particular disease. In that way, this decision making is very important with the help of AI. And third thing, the main thing of AI is it is used for data security and privacy. So what do you mean by data security? Means you're going to secure the data and you're going to use for n number of resources. What do you mean by data security? Means with the help of AI, you can able to provide, you can enhance the security measures by minimizing the risk and all. So AI in enhancing data security means, for example, you can say threat detection. AI first analyze the pattern, how to detect and prevent the security breaches. And moreover, you can say that AI anomaly detection, AI in that AI identifies the unusual behavior. If any behavior found abnormal means, you can able to indicate there is a threat has been happened. And moreover, you can have a clear response, how it can able to respond it quickly and how the security has been happened. And the third thing is with the help of AI and AI, I can able to train the models. I can able to train in the massive amount of, say, for example, you're doing some project. You'll be dealing with a massive data
Sorry
set.
for the interruption, ma'am.
Yes.
Ma'am, your screen is not being presented. Can you check it out, ma'am?
1 second. Is it visible, ma'am?
Yes, ma'am, it is.
Yeah, fine. Shall I continue? So
Okay,
right
ma'am.
now we are in the third point, how to maintain the data security and privacy. So data security here means for how to provide security in a very enhanced manner. So AI analyze the pattern, how to detect and prevent the security breaches. For example, if any unauthenticated person trap the network, means how the AI can able to detect the data, how it can able to protect the data in a very effective manner. So threat detection is very much important. So AI analyze the pattern, how to detect and prevent the security breaches. And moreover, it is very, very useful for anomaly detection also. AI identifies the unusual behavior which might indicate a threat happen. And moreover, you can able to get the automated response. AI can quickly respond to the incident, whatever it is happening. So it ensures the patient information to be stay protected in the way of encryption, providing the access control, and with the help of hack. There are two regulations acts are there. One is HIPAA and second one is a GDPR that we can able to that we can discuss further in a very detailed session. So HIPAA is nothing but it depends upon the US Act. According to the US Act, how the data, patient data can be kept in a secure manner. And second one is nothing but European Act that is nothing but it is termed as GDPR Act. According to GDPR regulation act, how to protect the data. According to the Europe Act, how to protect the data and keep the data of patient in a very safer manner. Unless until it is very important, with the help of patient knowledge only you can able to share the information. In that way, data security and privacy plays a very key important role in your data security for healthcare system. And the fourth point we are going to discuss is how it can be emphasized in personalized and predictive care. In this thing, very, very important thing is how the AI can able to balance the equilibrium state in maintaining the student patient history, how to manage the genetic information, how to incorporate the lifestyle pattern of the particular patient, how these things can be tailored into a healthcare way such that you can able to predict the patient record for the future things and all. And the fifth one, we are going to discuss about the operational optimization. How, with the help of AI, how you can able to forecast the patient character and the patient diseases and all, how to manage the things in a very good manner, stating with respect to the hospital resources, how to manage everything in effective manner, and overall, how can you provide the patient in a right way to treat that patient illness as well as to maintain the regular habit of the particular patient. In that way, you're going to focus this particular session. For this, the very, very important terminology, what we are going to discuss is this AI. So basically, all of you know about the basic impression of AI. So AI is nothing but very, very important. And moreover, AI is one of the important thing in mission intelligence. And moreover, in contrast to natural intelligence, this AI is used to describe the important cognitive function which is associated with the human beings. Then only you can able to solve a problem in a real-time environment. So AI is very much important for day-to-day activity. And moreover, with AI, you can able to do many splendid jobs and all. And next one, we are going to discuss about what are with the help of AI, you can discuss about the algorithm. So algorithm is nothing but you can able to say it's a clear way of instruction, that is without any complexity. I'll be giving the instruction to the system. With the help of system, I'll be getting the program output. So whatever you're going to feed into a system, that system is based upon the human intervention. With the help of human guidance, I'll be training the system in such a way that I can able to train the data. From the data, with the help of AI, I can able to learn the data, and you can able to manipulate the information in such a way that we can able to have a splendid knowledge. So with the help of AI, I can able to do a performance tuning. So with the machine learning, I can able to apply a subfield of artificial intelligence where I can able to ability to automatically learn and improvise the experience without being explicitly programmed. The next one we're going to discuss about the ANN, that is the artificial neural networks. So with the help of ANN only, a brain consists of lot many neurons will be there, lot many connectivity nerve cells and all will be there. So biologically, you can able to have one neurons can able to communicate with the other neurons based upon the connectivity, nerve connection only. So that thing will be discussed in the artificial neural networks. And data mining is nothing but when considered in a large database, how I'm going to generate a new set of information. That is nothing but mining. Whatever things you need, that can be digged out from the massive collection of database. The next one, with the help of cloud technology, I can able to use the remote access of the information where I can able to store, I can able to access the data whenever it is required. I can able to process the data with the help of the information. The next one, we're going to discuss about how this healthcare data security is very much important. So healthcare data security is a very, very important thing in nowadays. Without everything comes under healthcare only. Health is obviously a gift of God. And moreover, with the help of health, we can able to secure the data in a very predominant way. So what are the challenges you're going to discuss in the AI in the data security part? So AI models often require large data set raising from the privacy concern. Say, for example, if there is any potential leak, AI system might inadvertently reveal the sensitive data. So based upon the AI model can able to perpetuate the biases if trained on non-representative data. So balancing the AI security and privacy plays a very challenging one. So how you are going to safeguard these things means you should have a privacy or encryption to protect the real-time data. And moreover, there should be a transparency and control in order to understand how the AI can be used. So AI technique is used for enhancing data security, yes. How this security help in healthcare means security is in healthcare is very, very critical. And moreover, because of healthcare organization, in healthcare organization, everything will be handled by sensitive patient data. For example, you can say there is a cancer patient and there is a TB patient. So all this information should be kept under very secure manner, and there should not be any security breaches at any point of view. So you are in the position to protect the patient privacy. You have to ensure the confidentiality of medical records and the personal data also. So preventing the data breaches is very, very important, where you can able to provide a valuable things of sensitive information, so that sensitive information should be protected in case of any vulnerable attacks has been happened. So healthcare data is more valuable. An attacker tried to breach. Attacker tried to try to steal those information. In that thing, what is your role is you have to maintain the trust. So patients should trust the healthcare providers with the sensitive information. So there comes the role of this HIPPA for healthcare data security. What do you mean by this HIPAA? It is based upon the US Regulation Act. That is a protection of data where you can able to protect the data unless until without the prior permission of the patient, it is not possible to share the information to any kind of person at any manner. It also details how the healthcare providers need to control and how you are going to save or protect the data. So risk involved in the healthcare security is nothing but there are three kinds of risk associated. One is cyber attacks, second one is a data sensitivity, and third one is impact on care. What do you mean by cyber attacks? So healthcare system on target, there'll be some interaction of any malware or ransomware attack in the thing. So this data sensitivity is nothing but healthcare data is highly sensitive and more valuable. You have to provide a safer, secure mechanism in order to protect the data. And moreover, impact on care is nothing but there'll be a security breaches which can disrupt the patient care or compromise the safety. In this way only you can able to safeguard the thing. So with this help of this slide, is nothing but a representation of the healthcare transformation through AI. So AI plays a very important role in all this following sector. It is very much important. AI collection of data collection will be there, data pre-processing and integration. Machine learning can be applied with the help of deep learning, and you have to train the model. Then you have to collaborate with the human power. Then there is a continuous learning. In that continuous learning, there'll be some strategy how to improvise and real-time monitoring of the data, and some person will be giving some suggestion. That suggestion is nothing but a feedback how to improvise the system. After that, you have to make decision, a firm decision in order to predict what is the disease, what is the treatment you're going to provide. With the help of treatment, how I'm going to provide a sustainability. With the help of sustainability, whether the patient is safe from danger, safe from the particular illness. In that way, the transformation will be done. So let me discuss in detail about this following segment. First one is data collection. So collection of data is nothing but it can be done in a regular manner. With the help of AI, you can able to segregate the data. Whatever the data is useful, whatever data is very meaningful for giving the analysis part, that should be collected separately with the help of IoT device, and there'll be a medical sensors will be there. And with the help of medical data sensors, you can able to organize the data in a meaningful manner. And moreover, you can able to organize in such a way that you can maintain a record base, that is electronic health record, where the information will be collected month wise, year wise. You'll be collecting all those data and arranging in the order, and using the MRI scan, that is nothing but using imaging device. I can able to using a scanner, MRI, I can able to know the information. I can able to diagnose the patient information. What is the stage? What is the current stage? Whether they belong to stage 1, stage 2, stage 3, stage 4. The stage, when the earlier stage detection means you can able to cure the disease easily. With the help of AI, I can able to predict what kind of disease are there. So if there is a stage is very high, means stage 4 means we can't able to stop the disease spread or not. That's all. So using this imaging device, you can able to diagnose a early condition, and you can able to prevent the patient with the help of many techniques and all. Using a smart gadget, such as known as wearables, right? So smart watches and all, it can able to assess the human health condition. What is the fitness thing? How much time? What is the use of smart watches and all? It can able to maintain the human fitness and all. So this ensures the availability of raw health information for further processing. For example, if my pulse rate is going down, means I can able to provide certain, I'll be taking a preventive measure, how to improvise my health condition and all, BP meter and all. I can able to cope up with the things, how to improvise further. So this data collection is very important with the help of AI. The next one is the data pre-processing and integration. What do you mean by data pre-processing means? You will be collecting the data randomly. That random data will be not be completed one. It consists of lot many distortion, that is noisy. It can be stored in various platforms and all. In how these things can be organized together without any flaws and all, without any incompleteness. You have to collect the data, and you have to try to collect in a meaningful manner so that you can able to integrate those data, and you can able to produce a valuable result so that the doctor can able to provide a valid concern in this thing. For that one, it's very important. So you will be collecting the data in the right manner so that pre-processing can be done in an efficient manner. For that, security plays a very, very important role. So how this role of AI in data security means, first thing you have to detect the things and all. Data pre-processing is very much important for security. The next one, we're going to provide machine learning and deep learning concept. With the help of AI models nothing but is a combination of machine learning and deep learning technique. It is used to learn the real-time data, what are the patterns are there, what are the prediction, what are the anomalies are found, what kind of prediction you're going to predict. For example, if there is a heart attack patient coming for consultation, with the help of AI, I can able to detect the patient in history. I can able to assess with the help of AI model, I can able to assess them. What are the things to be do? What are the things to should not be not do? So like that, I can able to diagnose with the help of medical images and can able to provide a valuable services. And how to train this? Fourth one is how to train the model development. So AI models are very, very important when taken care in the large data set. That is of patient information. The goal is to improvise the prediction accuracy. Thereby, always there should be a prediction accuracy will be very much important. Without prediction, I can't able to go for the treatment plan and all. So ensure that there is a reliability also for that proper algorithm should be implemented. With the help of AI, I can able to predict, I can able to gain the accuracy and have a very good reliability. And moreover, there should be a continuous model update with the system alignment for new medical research and patient records. The next one is decision making and prediction. So based upon with the incorporation of the AI method, that is artificial intelligence, the system can able to provide a very good support for diagnose the problem and what kind of treatment is suitable and what kind of recommendation I can able to perform and what is the output based upon the prediction, diagnostic and recommendation. That is very much important for decision making. With the help of decision making, with the help of AI, the doctor can provide a very good decision. So based upon the input of the AI, the doctor can able to give their inputs so that a best treatment plan can be done. With the help of best treatment plan, the patient can able to recover from the illness in a faster space. That is very much important, where I am going to minimize the human error. And the sixth one is real-time monitoring and feedback. Real-time monitoring, daily I can able to take the pulse rate, heart rate and all, oxygen levels and all. So once the patient will be wearing the smart watch will take care of the oxygen level, what is the pulse rate, what is the heartbeat, and what is the level of BP level and all. Everything can be provided in the notification of the mobile phone. So using the mobile phone number will be shared to the caretakers so that the caretakers can able to find the real-time information about the patient so they can able to provide the proper care for the belongers so that I can able to provide the hazardous things happening in the patient. So with the help of smartwatches, enabled smartwatches will be providing a very good system services for real-time monitoring, such as heart rate, oxygen level can be monitored, glucose level can be maintained easily. What is a health fitness, all the information can be catch in the real-time environment. So with the help of this real-time environment, I can able to go for the further treatment plan very easily. Illness level also can be minimized. The next one we're going to discuss about in the healthcare transformation through AI, we can discuss about the continuous learning and improvement. With the help of AI, I can able to improvise a system by learning from new patient. With the help of patient recovery, I can able to provide a real-time suggestion, feedbacks and all. This feedback is very much important for predicting the level of accuracy of the patient and the illness. And moreover, I can able to suggest for new things and all. Based upon the recommendation, it can be able to analyze the accuracy level, what is the adaptive method, how the system can be personalized with the particular patient. All the stuffs will be plays a very important role in the continuous learning and improvement. And the eighth one, we're going to discuss about human AI collaboration. With the AI means I can't do anything. With the help or support of human, I can bring a lot many marvel things can be happen. With the help of AI, I can able to rock the medical field. So AI, with the help of AI tools, I can't able to replace the AI with anything. I can able to use the AI tools. I can able to help of AI tools in coordination with the healthcare professional. I can do a marvelous thing in the medical field. So with the help of doctors and nurses working with the help of AI system, I can able to give a clinical expertise, that is AI driven insights, which is very, very safer and give a best feedback result and more personalized to the prediction of the patient illness. And you can able to give an extra care to the patient we need for the particular thing. So these are the healthcare transformation can be done. And this is a schematic diagram which defines the categories of AI. So categories of AI means you can roughly say what do you mean by AI. So AI, with the help of AI, you can able to do many more best things and all. So with the help of AI, I can do many things, but AI is very much important in day-to-day life. So with the help of AI, I can able to rock in anything. So AI is nothing but it is based upon the computer system. I can able to perform a certain perform any task, right, requiring the human intelligence. Without human intelligence, AI cannot perform. So these tasks include learning. I can able to problem solve the particular scenario, and I can able to provide a very good decision making and better understanding of the patient records and all. So basically, with the help of AI, I can able to adapt to any kind of any kind of environment and improve the overall time. And moreover, interaction with human can be very, very understandable. So with the help of AI, I can able to diagnose, I can provide a very good information, that is a very good suggestion for doing the recommendation for the particular problem. So based upon the AI, I can able to categorize, there are different categories of AI. Say for example, if AI is there means, how can I able to rate the AI? AI can be rated in three ways. That is, you can able to categorize, there are three classification. First one is your weak AI. Second one is your strong AI, and third category is nothing but super AI. So what do you mean by weak AI? With the help of weak means it's very, very not clear. Weak is nothing but it can able to perform only a limited task. It can't able to perform more than one task. That is known as weak AI. It is we not have a capacity to learn further. Strong AI means with the help of AI, where human intelligence plays a vital role. With the help of human intelligence, I can able to create a model which can act very strong. That is nothing but strong AI. Super AI is nothing but in a very massive environment, I can able to do any kind of activity, irrespective of the quantity. I can able to provide a very good knowledge. I can able to provide very good service plan, treatment plan. Everything can be done. This can be done in super intelligence. So let me discuss in detail about the various types of AI. So weak AI is nothing but already we have discussed. It is not comes under your mission intelligence. It's a non-sentiment mission intelligence. It focus on very, very little task, narrow the task. Strong AI is nothing but with the help of AI, artificial general intelligence, a machine can able to apply the intelligence for any kind of problem. The problem won't be a specific. It can be anything, small scale problem or medium size problem or very massive big size problem. It won't address for the simple problem. It will address for any kind of problem irrelevant to the data. It can able to think very smart so that it can give a very best in result for the using after applying this artificial general intelligence. And the third thing is nothing but super intelligence. Super is nothing but something extremely more superior. So super thing is nothing but with the help of artificial intelligence, I can able to bring the brightest gift of humankind, which is helpful for self improvement, and moreover, you can able to expect a more creative thing in a super intelligence. So with the globe is nothing but consists of various countries and all. Now with the help of AI, all the country around the world, it depends upon the AI. So let me have a basic information about what is the timeline of AI in healthcare. Basically, this AI concept has been coined in the year of 1956 by the researcher named as John McCarthy. He founded an academic discipline with a very good basement. From 1960 to 1970, they introduced the AI problem solving concept. It's the first problem solving program, where it known as dental. They can able to assist identify the bacteria, recommending the antibiotics in the year of 1960 to 1970. And in the year of between 1980 to 1990, there comes the role of microcomputer, where different level of connectivity has been established. With the AI, this is the first coined thing where AI system healthcare were designed to accommodate the perfect data. By the help of clinical physician, they built a system which is very, very expert in defining the problem in real-time situation, how to address the patient care. In that way, they define. And in the year 2010 to 2019, there comes a genomic sequence database where the electronic health record system has been played a very important role. So natural language processing, computer vision, robotic assisted surgery and all come into role of action. And from 2019 onwards only, there comes a preclinical. Moreover, researchers all over the world give a special care intention how to establish more productivity in the AI with the help of giving a personalized healthcare treatment has been done. So this is the timeline of AI in healthcare. So AI rocks in many fields such as in patient facing, telehealth, in wearable devices like smartwatches. We can able to monitor the real-time data, real-time information, checking the pulse, checking the heartbeat, checking the pedometer with the help of what is it, foot count and all. Foot count, daily count, how many steps you have been taken so far for reaching one building to other building, or going for small walk means how many calories you have burned. So personalized genetics has been done. Mental health condition can be monitored. So how to take medicine, when to take medicine, like that. Using a small gadget, I can able to personalize my system so that I can able to have a alert in the watch and dog. The research mainly it is used in drug discovery, information clinical trials, in genetic research and all. Mainly in hospital, AI plays a very important role in fixing the appointment, booking the slots of the expert person, virtual appointments, and many things. This AI plays a very important role. And these are the areas where AI rocks in a very good manner. And AI in healthcare. So AI in healthcare is nothing but artificial intelligence. So being artificial intelligence is nothing but it is transforming a significant big transformation healthcare by enhancing the patient care, optimizing the workflows and all. So optimizing the medical workflows and enabling the more accurate diagnosis as seen in the image. With the help of AI, you can able to provide a very good services for patient in the way of where there is a if there is an absence of live thing means in a physical meeting means we can able to provide a patient facing services like chat boxes. By using a smart wearable watches, I can able to predict the health things and all. Using a via telemedicine, I can provide a very good recommendation of the medicine by using a personalized genetics and all. So using AI now, all of them are using AI chatbots to help to address the patient queries and all. Using a wearable devices, I can able to keep track of the vital signs telemedicine platform to make the remote healthcare more accessible. And these innovation empower patients to take charge of their health by reducing the burden of traditional healthcare facility. So AI is very, very important for lot many things. And moreover, along with the facing the doctor, AI also supports the medical profession, how to improvise the electronic medical records, how to keep track of the records, how to manage these records and all, disease records and all, how to strengthen the medical imaging analysis. Precision analysis can be done with the help of AI. And moreover, this data analytics platform powered by AI helps doctor to identify what is the exact disease, how to analyze the risk rate and all, and what are the further treatment plans can be done so that the treatment of illness can be curable or not. In that way, you can able to focus with the help of AI. For example, AI in imaging is nothing but, for example, there is a patient who is having a tumor in the first, there are different levels of tumor. For example, if they are analyzing the earlier stage, first stage itself is very curable, and moreover, with the proper diagnosis, I can able to eradicate the occurrence of the cancer. If the treatment comes in the second stage means you have to diagnose the problem and address for the particular patient, and you have to give the proper treatment. After several treatment, after further future plans and all, you can able to provide the medicine via the treatment procedure. If the patient coming under fourth stage means it is incurable, but there is a decision of support can be done, and you can able to have a balanced lifestyle for giving the last stage of things. So based upon the research and innovation space, this AI accelerates the drug discovery in clinical trials and in genetic research and all. By analyzing the massive data set, so in cancer data set, cancer patient means they'll be having a lot many person under the same category, they'll be having different massive data sets and all. How AI can able to identify the drug and which compound is from human being to from person to person, the drug meditation will be differ based upon the immunization power, based upon the human body accepting condition, it may vary. So how faster the traditional methods can be done, predict the trial outcomes and explore the personalized medicine through genetic analysis. So hospitals are also adopting AI system to manage the operation more efficiently to optimize the patient flow and improvise the resource allocation. So overall, AI in healthcare creates a very, very important thing. And moreover, it creates a collaborative ecosystem where the requirement of doctors, nurses, researcher, patients, and all institutions work very, very together, smarter together to deliver the best and very effective way to provide the healthcare solution. More personalized healthcare solution is the emphasized term. With the help of AI, you can able to provide a very good personalized system. So no longer science fiction, AI is transforming the healthcare. With the help of AI, I can able to provide a very good training and proper research to provide a very good life care at the end of life care. And the treatment of well diagnosed makes a very good decision making, diagnose the earlier direction and keeping well of the patient. So AI with the help of robotics joining together provides an n number of transformation. So let me discuss in detail how the transforming healthcare has been happened from AI together with robotics. In researchers and all, many researchers along with AI, they assist the medical research with big data analysis. They help to discover a new invention of the drug items to predict the disease pattern and test for the real-time environment and simulate with the clinical trials. This helps for the patient to relieve from the illness very faster manner. And moreover, training is required for doctors and nurses to treat the patient with utmost care and utmost well advanced. So with the help of AI powered simulation, we can able to provide the best services to the patient with the help of trained doctors and staff nurses and technicians. And moreover, you can able to treat the patient who is having a remote access. So robotic surgery trainers can improvise the skills with the help of AI. They can provide a very good solution to the patient without any risk. And keeping well, third point is keeping well. So how one person can able to track the health records in day-to-day life is using of smart watches. Now there are more smart watches are there, which is giving a very excellent services and all. With the help of smart watches, we can able to provide a daily assessment. What is the functions are going of smart watches. With the help of smart watches, I can able to provide. With the help of smart watches, I can able to provide n number of functions. So smart watches can able to provide a very good entertainment services, and basically it is used to track the fitness and health metrics and more personalized wearability. So with the help of smartwatches, I can able to monitor the day-to-day routine activities such as walking steps, heart rate, sleeps, workout, and notification of the health records. For example, if the pulse rate is going down, for example, if I'm feeling very anemic, my pulse rate is going down means with the help of smartwatches, I can able to understand what is going inside. So I can able to consult a doctor for further processing. So personalized health recommendation to maintain the wellness can be achieved. And moreover, you have an earlier direction. AI detects diseases at the earliest stage, such as heart issues, cancer, TB, and many more things, and all Parkinson disease. With the help of these AI sensor, I can able to stop the further occurrence of many more things and all. So with the help of scan images, such as image recognition, that is medical images like radiology, pathology, and genomic improves the more accuracy with the help of imaging services. And diagnosis is very much important. With the help of diagnosis AI, I can able to support the doctors with very faster rate to quick diagnose the particular patient illness. So it reduces the human error by analyzing the symptoms at the earlier stage, and scans help to understand the real-time information about the patient illness and proceed accordingly by giving a very good world-class treatment. And the lab reports are very supportable to address the queries and all. The sixth point is nothing but decision making. So decision making is nothing but you have to with the help of AI, I can able to choose which treatment plan is very much suitable for the particular patient. With the help of AI, I can able to provide a very good decision things and all. So data-driven insights are for personalized patient care plans help us to give more decision, very good decision in a shortest period of time. The next one is your end of life care. So sorry, treatment. Treatment is nothing but with the help of the surgery and all, there'll be a very complex surgery has been happening means, for example, kidney replacement, heart replacement. There'll be with the help of robotics, I can able to provide a precision surgery with minimal invasiveness. So AI can able to tailor the medication and therapy for individual patient and giving more excellence in the medical system. So end of life care, AI helps to monitor terminally ill patient with lot of dignity, and it provides a very good recommendation and supports a caregiver by giving a very good suggestion and very good splendid recovery systems and all. And what are the best things are found in the AI using healthcare in AI? What are the best things found in AI means it is used for diagnosing the particular diseases at the earlier stage That is, you can able to provide an enhanced diagnostic accuracy, and you can able to support for personalized treatment plan, and there's a predictive analysis, early analysis, and early detection, and you can able to provide a very good healthcare management, and you can able to access the patient, monitor the patient at remote area, and you can able to provide the telemedicine. Through telemedicine, the remote patient care can be done, and you can able to provide a very good drug discovery and development process. So this treatment plan helps you to So the moreover, the patient may feel alienated if machines or replace face-to-face interaction. Importantly, in sensitive cases like mental health, palliative care, or end-of-life care, so lack of human touch and empathy is very, very less. And moreover, potential for errors and bias. So biased data sets can lead to unequal treatment based upon the gender and based upon the race conditions or all. So that means there's a chance of errors in algorithms may go unnoticed until it harm occurs. So continuous periodical monitoring should be there. Continuous validation, updating the AI models are required, which helps to give a better treatment plan. And moreover, there's a privacy and data security concern. So what do you mean by privacy and data security means? For example, healthcare data is have to be kept in very highly confidential. There should not be any unauthorized person to monitor the system or hack the system, or sharing of data should not be done. Unauthorized person can't be able to penetrate. In that way, you have to design a system. There is some risk may be involved, unauthorized sharing, misuse by third parties. If any mistakes, if the health record has been trapped by some other person, means you have to give a proper security for all the things and all. So all this record sensitive information data should be accountable and should be taken care under the Act of HIPAA, that is Health Insurance Portability Accountability Act, according to the US government, and Europe government also they, that is known as General Data Protection Regulation, that is GDPR. It is very, these two acts are very much important, that is HIPAA and GDPR Act is very much important for privacy and data security concerns. Another disadvantage found in healthcare using an AI is nothing but limited interoperability and transparency. Many AI system functions are black boxes, make it very hard for doctors to justify the AI-driven decision. So lack of transparency may reduce trust among the patient and medical professional. And explained by AI, XAI is being developed to solve these issues. So integration challenges and resistance to adoption. So hospital may face maybe very high cost implementing this AI system, but this AI, the help of this AI system is not affordable to all kind of people. So technical incompatibility with legacy creates more delays and all. So doctors and staff may resist AI adoption due to fear of job replacement or lack of training. Because if everything is AI doing, means what is the role of doctors and nurses and all? So it's a very quite bit challenging only. So ethical dilemmas and accountability. If AI makes a wrong diagnosis, there is a flaw in diagnosing the proper treatment plan. Who is responsible? Who is going to address the particular issues and all? The doctor or hospital, or who is going to designer who will develop the particular AI. So over reliance on machines may weaken the clinical judgment. So ethical concern about the data ownership. So as the patient data belong to the hospital, patient or AI company, that's a very, very challenging one. So role of AI, role of artificial intelligence in healthcare. So technology application and apps encourage healthier behavior in individuals and keep with the proactive management of a healthy lifestyle. So additionally, with the help of AI, you can able to provide a very good trained professional, healthcare professional for better understandability and day-to-day patterns and need to learn and need for the people they care for better feedback and for very good support and provide a very good guidance also. In health monitoring, how this AI is very hacked in a very smarter way. So wearable health trackers helps you to track the day-to-day updates of your health domain. For example, you can be able to use Apple, Garmin, Fitbit or not. So these monitor the health rate and activity levels of your heart patient. So So they can send the regular updates on your mobile phone or through your smartwatches, alerts to user to get more exercise. For example, a heart patient is not walking properly. Daily 1 hour walk is mandatory for health a heart patient. They're not going for a regular walk means automatically through the AI, smartwatches can able to provide a signal notification stating that go for a walk for half an hour, go for a walk for another 1 hour, go for a walk in the evening time, go for the walk before the bed. Like that, it can provide an alert notification so that the patient can able to recall everything and go for a walk for betterment of lifestyle. So there are some journal papers refer what is the role of AI in chat box and future of medicine. So this is a digital oncology. It speaks about the cancer, how artificial intelligence plays a very vital role, tremendous in chat boxes and future of medicine. So medical chat box it can able to provide a high quality of information, reassurance, answers, and way of thinking. Is something sensational about the situation related to the human behavior. So already in the 1995, Dr. Greeny has discovered lot many things in the online and the people search for the answer. What is a healthy question was absolutely inevitable. It would soon be unthinkable not in a learn online. Our job was to help create and point to reliable information online and to teach how to find, judge, and use it wisely. It was to open school has done for many years regarding the oncology research. One could see our patient population as different. Mind focusing on the beginning of life, years often towards the end. Yet we have found that there is a quite the overlap. A patient thirst of knowledge, disease develop unpredictably, and treatment plans shift frequently. In the oncology, that is in the cancer thing, the cancer based upon the cancer patient, they given one statement that day by day the treatment plans are quite very amusing, and moreover the treatment plans going on changing continuously. There is no fixed treatment plan because based upon the illness, based upon the condition of the patient, the treatment may vary from person to person. So the illness may vary in a rapid speed of time because tumor cells will be growing endlessly. The size also will be going very variantly. So according to that, treatment will be going off. So for that, the medical chat box plays a very important role. How AI with the medical chat box plays a rocking technology in the healthcare that described in this particular paper. Role of artificial intelligence in health to detect disease, n number of diseases more accurately at the earliest stage itself. According to the American Cancer Society, a proportion of mammograms, the mammogram is nothing but a sudden abnormality found in the chest region, women's chest region. So one this past result leading to 1 to 2 healthy women being told that they have a cancer. So that this cancer can be diagnosed in the earlier stage and it is very curable at the earlier stage duration. Yeah, at the very faster growing the stage 1, stage 2, before the earlier stage it is very curable. At the early stage also very curable, but in the stage 2, stage 3 means you can able to find the best treatment plan so that spreading can be avoided. So using AI mammograms 30 times faster with 99 accuracy, reducing the need for unnecessary biopsies because biopsy leads to lot many severity to the patient and it could charges also heavy. So not to avoid those things, a proper treatment plan is guided so that you can able to give a very good AI supportable treatment plan. So Google DeepMind Health is working in partnership with clinicians, researchers and patients to solving detecting a real world healthcare problem. So they provide a very good spender services how to treat the mammogram patient for early detection among the human. So while it has been detected at the earlier stage means the treatment plan is very simple and easily affordable by all kind of people. So researchers are still finding a very best solution. Already solution are there. They are leveraging the solution things and all. Another thing about this AI is nothing but it plays a very important role in eye also, diabetic retinopathy. That is, a patient is having a diabetic retinopathy. How the screening has been happened in Africa. There is a paper it published in Lancet Digital Health about the artificial intelligence title known as Artificial Intelligence for Diabetic Retinopathy Screening in Africa. The author is Wangfu Klu Martinez. It was published in the year of 2019. They discuss about the blindness from diabetic retinopathy. So diabetic retinopathy, they need a proper advice treatment plan should be there. If there is a neglection in treating the diabetic retinopathy means there is a chances of having a vision loss also be there. So high health system with low resource countries This is driven by rising the number of people living with diabetics all over the world, with the largest increase in projected, especially in the areas in the countries like Asia and Africa. So despite screening of diabetic retinopathy in the diabetic retinopathy status, without waiting for feedback from reading centers, which often associates an extra journey of them, the article describes a tested methodology using a convolutional neural network and its effectiveness in reading images African patient, although Belinomo and colleagues finally reassembled the model. At a later stage, with the help of AI, the dynamic retinopathy, which has been done a remarkable significance. So using AI for digital retinopathy screening will allow the non-clinician to be trained or retina imaging, obtaining the interpretation of the images within the minutes and thus giving an instant feedback. So with the help of AI, if I'm going for digital retinopathy means the treatment plan is very, very simple. No need to wait. The patient can able to diagnose the problem and give the instant relief from the particular problem. So this is nothing but a early detection. This is one of the example AI with the healthcare. Another thing is, what is the role of AI in artificial intelligence in health? According to in the IBM Watson for Health, there is a helping healthcare organization has been reviewed and they store lot many medical information. So every medical journal, symptom, all the case study treatments and response around the world are exponentially faster than human. They can able to predict the disease severity and the patient health condition and give a proper vital treatment plan. Using a medical imaging is nothing but MRI, scan images and all, X-rays. So machine learning algorithms can process unimaginable amounts of information in the blink of eye and provide more precise treatment plan for the humans, spotting even the smallest detail in the medical image. With the help of medical image, I can able to diagnose a problem. I can able to find out what is the severity involved in the particular process. So everything can be done in a very short span of time. The company known as Zebra Medical Vision is a new platform known as Profound, which analyze if you are giving any medical imaging report means you can able to diagnose the condition and you can able to provide what is the problem, what is the illness, what is the stage of the illness, very it curable or not, what is the treatment plan is required, for how many days the patient go for the treatment. 90% with 90% of accuracy, they can able to provide the explanation. So this is one of the services done by AI. Next one, the another journal publication from Nature is a very, very important one and is most significant. In this title of this particular journal is nothing but dermatology, skin problem. So dermatologist level classification of skin cancer. There is another cancer that apart from heart attack, liver disease, cancer and all, brain cancer, tumor and all. There's a skin cancer with the help of deep neural networks, how they are providing a suggestion. This AI trained convolution neural networks using a data set about 1,29,450 clinical images to classify a type of cancer. So they can able to provide a very good treatment plan and suggestion how to overcome this cancer. So everything under the diagnosis, they can able to provide what is the classification, what is the recommendation for the particular system. Using an AI, they can provide a solution with the help of AI system in healthcare. So the role of AI in healthcare. So improving the care requires alignment of big health data that should be very, very appropriate and timely decision. That is very much important. Without time, if I'm going to provide the decision means is useless. With the help of time, with appropriate digital health, we have to provide a very good support using a clinical decision making. So that makes a very effective in the administrative level. So digital consultation is very much important. According to the doctor in the AI, they provide a Babylon in the UK. Their use of medical consultation provide a very best personal medical history and common medical knowledge using these report and symptom in the app, which uses a speech recognition to compare in a database of illness and ask the patient to specify the symptom of triage, whether they should go for ED, urgent care or primary care doctor. So based upon the people recommendation, the patient is coming and addressing about the problem in a remote way, but he can't able to consult the doctor in live manner. So he's going for digital consultation. In the digital consultation, then the system is asking what kind of symptom you're undergoing. So the patient has to record the information about the symptom. What are the symptom he's facing? What are the abnormalities found in the particular patient? So based upon those diagnoses, with the help of AI healthcare system, it can provide a very good, fantastic treatment plan, whether he has to consult a doctor or dispensary treatment in an urgent way or emergency. Like that, they can provide a classification. So this is an advancement found in your AI with the help of healthcare. Another one journal known as PLOS Journal, the research article titled "A Data-Driven Artificial Intelligence Model for Remote Triage in the Pre-Hospital Environment." So the author are Doyin Kim and Yu and So and Lee, Yuk Dong Poyokang, Yung Kim, and Yukong Park and Co. He discovered about in the mass casualty incident, the factors that determine the survival rate of injured patient are diverse, but one of the key factors is the time for triage. Additionally, the main factor that determines the time for triage is the number of medical personnel. However, when relying on small number of medical personnel, the ability to increase the survivability. After the incorporation of the patient of the cancer thing, the survivability very less. When the patient has been determined in stage 4 or stage 3 means the survivability is very less. At the earliest stage, the survivability very more. Always you have to protect yourself under the earlier stage reduction. That is very much important. So with the help of AI, we can able to protect our things in a very faster spaces. Unless until we should have a knowledge to share and give the proper diagnosis. So in today's world health emergency, there are numerous and medical personnel are limited. The study has been designed to consciousness index to substitute the factor by manpower. With the help of we are replacing manpower by AI to improve the classification accuracy by applying the machine learning algorithm. This is also one of the fantastic work done in the artificial intelligence. So treatment plan vary from person to person. With the help of AI, you can able to analyze the data, you can able to analyze the report of the data of the patient, and you can able to find out the research, what is the clinical expertise is required. To help the select correct individually customized treatment plans also available. According to the affordability of the patient, we can able to provide a very good treatment plan. So precision medicine is also involved based upon the massive population amount. There are very different kinds of treatment, making the same medical decision based upon the few similar characteristics among the patient medicine has shifted toward the prevention of personalization and precision. So genetics and genomic look for mutation and links to disease from the information like DNA. With the help of AI, the body can scan the spot of the cancer and vascular disease early detection and predicting the health issues might face based upon the genetics. So with the help of precision medicine, we can able to understand what is under which segment, under which area the cancer cells are growing, what is the correct best treatment plan, and how we are going to overcome from the particular illness, what are the proper treatment plan recommendations required for further meditation for the particular patient should be done. So this and all will be taken care of the AI in the healthcare system. The next thing journal we're going to discuss about expert review. So expert review of precision medicine and drug development. In this, the role of artificial intelligence in precision medicine by Atal and Mesco. He's a very good researcher. His technologies such as genomics, his area of research is based upon the biotechnology, genomics, and wearable sensor. Based upon the artificial intelligence, the three major directions have been found. First, you have to make the patient point of care. Care should be taken for all kind of patients. That is very much important. So what is the volume of data that should be taken care by analytics? And third one, precision of medicine. So person to person, the medication will be vary. So you have to diagnose with the proper precision medicine. Along with that thing, a drug development has been designed so that you'll be giving a very good care. So this is one of the best paper who got the award for best presentation. And next one is the role of intelligence in healthcare. We are living so much longer than the previous generation. As they approach the end of life, we are living an end of care. How this end of care can be given? We are dying in a different and slower way from condition like dementia, heart failure. Nowadays, people are giving a sudden threat like today we are seeing one patient, next day that person is not there. No more because of sudden failure, heart failure. Some persons fall because of dementia. Some person has been lost his life because of osteoporosis. Some persons giving the thing sudden cancer, last stage of cancer. So the person to person, many diseases are happening. Many diseases due to diseases only the patients ending their life. It is also the phase of life that is often plagued by loneliness. So AI gives a very good conversation of the social interaction with the people, keeping the mind sharp. So meditation is very much important, how to improvise the client adherence and all. So according to that, there is a foundation known as National Institute of Health, which have been created an app that is AI Cure app, that is artificial intelligence app. What is the role of this AI Cure app? It is able to monitor the meditation of the patient. What is the right medicine? What is the right time to take the particular medicine? What is the dosage level at and what is the after taking the medicine, what is the diagnosis, what is the symptom for the particular patient, whether he can able to carry forward the medicine or not, what is the further treatment plan, everything can be diagnosed by AI Cure app. Once you input your parameter, patient parameter, according to that treatment plan will be delivered. When to consult the doctor for further things and all, everything through using a webcam, they can provide a remote virtual environment recommendation also. This is thing very good, important, welcome in the Western countries and all. This AI Cure app is very much rocking in the Western countries for providing endless services for medical domain. And next one is based upon the molecular epidemiology. So artificial intelligence and machine learning reshaping the health research and innovation in the field of molecular epidemiology. So recently there is a very greatest foundation found in the statistical computation challenges molecular epidemiology. This is the basic thing focuses here is to identify and characterize the genes which interact with other genes, how the gene interaction can be done. What are the environmental factors which is associated for bringing the gene interaction? What is a complex of multifactorial disease? So everything can be well explained this particular thing. Research has been going there. So with the help of this particular concept, it can able to solve the traditional statistical method due to high dimensionality of the data, and moreover, polymorphism can be reduced, and moreover, several in this particular field of research, many machine learning methods can be associated, such as neural networks, SVM machine, support vector machine, random forest machine, in order to identify the different level of multifactorial disease. This is one of the beautiful things in the research. So in training, AI allows this particular diagram. See this diagram. It consists of training, validation, and testing. Here the stage is ready for particular medicine. How the AI artificial intelligence allow in training through naturalistic simulation in way the computer algorithms can perform. So basically, the natural speech of ability of AI, which can be able to draw instantly on a large database scenario, which can provide more questions, more queries can be generated, and based upon the recommendation, a very good decision can be taken for the trainee to challenge the human check where humans cannot. And AI in the robotic surgery. So many missions, many challenging surgeries can be done with the help of robotic surgery. Now robotic surgery is very, very common for knee replacement in all hospitals in across India. Everything comes under robotic surgery, comes under knee replacement. They are doing a splendid performance in knee replacement. So with the help of robotics thing, all the information, more than 30 years, surgical robots can either aid a guide or human surgeon and execute operation themselves. They're also called used in hospitals, labs for doing the repetitive task and all. So that's physical therapy and also involved for this particular long-term condition. So the robotic surgery is very much important in replacement, and they plays a rocking role in the heart transplantation also. And the role of AI in public health. So role of AI in the public health is used in disease prediction, it is used in epidemic prediction, it is used in screening, and moreover, with the help of AI, I can able to process or treat the water also. In many fields, the AI is very much important. Another very good research paper found in this particular AI is nothing but research showing AI may help diagnose the tuberculosis in remote areas that captures a Magnus Award. What do you mean by tuberculosis? Tuberculosis is nothing but TB, right? It relates to the very, very important thing. It's a life-threatening disease in the earlier 18th century and all. There is no proper treatment for treating this tuberculosis. Nowadays, with the help of AI, there is a splendid advance comes under AI. So they can able to give a proper treatment plan, and it's very curable also. AI solution provide a low cost and accessible excuse me. With the help of AI, I can able to provide a TB reduction to vulnerable population, particularly throughout the Southeast Asia, China, and Africa. The company already, there is a company working towards in the particular TB reduction, which costs less than $1 per scan. So using this, the X-ray should be taken for TB diagnosis and all. The cost of TB X-ray also less than $1 only, because the solution is the X-ray device to work. It can be able to correctly map what is the level of TB, what is the spread rate, what is the proper diagnostic plan, what is the treatment, what is the pills to be taken. So everything can be done in a very remote manner, so that the patient can sitting in his place can get the treatment plan and get the medication and get the survivability. So everything can be done in a one way, in a one place. That is a significant found in this particular research. So treatment diagnosis of tuberculosis in remote areas. Hoping to bridge the gap of Paras Lakshmi MD from Thomas Jefferson University Hospital in Philippedia, they have been governing the proper treatment plan of investigating the efficacy of an automated method for reading the TB on chest radiograph. Especially, they have pre-trained the convolutional neural network to identify the TB on chest X-rays. The results of this research, deep learning at chest radiography, automated classification of pulmonary tuberculosis by using the CNN method, that's convolutional neural network. They published in the year of 2017, where remarkable appreciation has been done. This is also one of the significant advancement in the field of AI in healthcare. And this is a very important thing. Next generation, the public health surveillance, how the automated healthcare data, informal sources, community engagement, artificial intelligence plays a vital role. So community input will be there. So there is this diagram defines above how this public health surveillance has been done based upon the information in the area ways map ways, how the people can able to identify what are the area, where is the community input, what are the informal sources, how the contributor has been addressed now, how the post of public can able to identify the disease, how to treat the disease, how to make the keep the healthy people healthy habit, how to prevent or control the disease, how to strengthen the size with the help of AI, how to nullify the disease occurrence and spreading rate and all. And when the disease happens, how to stop the disease. Everything can be narrated in this particular diagram. So next generation public healthcare surveillance is nothing but it is an automated healthcare data collection from hospital, clinics, wearables, IoT devices and all. With the help of IoT devices, can you provide a remarkable services how to nullify the disease rate. And moreover, integration with health records, electronic health records, lab reports, imaging and generic data, we can able to provide a real-time solution how to give a best treatment plan for the particular patient. And moreover, early detection helps to stop the disease occurrence and you can able to spread this faster rate also. And using a predictive analytics, you can able to forecast the healthcare demands and resource needs also. And in community engagement and AI-driven healthcare, it can able to contribute mobile health apps and all. So you can able to conduct a survey, online survey, and there are many campaign will be conducted for telehealth platforms and all. How the tracking of disease trends, how they with the help of a chat box, how the virtual assistant or patient education or self-care guidance can be done. So public awareness campaigns enhanced with AI targeted communication can be done. So these are the best things found in your with the help of AI. And the role of AI in healthcare surveillance is used in machine learning. With the help of machine learning, I can able to detect the hidden path in the massive data set. This is a large data set. Using NLP, I can able to analyze the medical reports data, how to interact with the social people, how to get the information from the news channels and all, how to provide a healthy signal for using NLP, you can able to provide. Using a computer vision, I can able to find out identify the anomalies by using a public health scan report. By using a predictive modeling, I can able to anticipate if there is any shortage in the drugs and all. I can able to nullify the thing. I can able to minimize the health risk found in the healthcare, and moreover, how it anticipate outbreaks and all. And moreover, with the help of decision support system, I can able to provide a very good timely support to help the private hospital, government hospital, and many more people across the globe. And another thing I want to discuss about, this is a very important thing in the healthcare during the last phase of the pandemic situation. There is a dengue and all. The dengue, how the AI plays a very important role in dengue forecast in China. So this study used in the combination of case report of Baidu, where China's top search engine, search queries and climate factors and all. Moreover, they compare with the working models, how to provide a best significant role, how to nullify the occurrence of dengue, how to give the how to give the important treatment plans in order to rectify the occurrence of the dengue forecast. So everything can be done with the help of AI disease prediction. You can able to stop in a wider perspective. So acceptance and scope of the AI in the world is there'll be different strategies are there and there'll be a best acceptance level, and many researchers are finding valuable time for researching for giving the best outcome for the future investment of the tomorrow younger world. What are the strategies found in the government services? So governments and organizations are creating very various AI strategies for healthcare in the field of healthcare, robotics, industries, education domain, public services and all. So many strategies are help for transparency and accountability for AI prediction. And moreover, well-advanced countries like US and China, India are giving a natural AI roadmaps for driving the innovation. So acceptance level is there's a many autonomous vehicle will get services by using smartwatches. You can able to access to AI. Public trust is going AI to improve the efficiency by providing a very good accuracy in the treatment plan, and moreover, the affordability for the people for saving the cost of treatment. And moreover, there is a wider acceptance depends on addressing the concern about the privacy bias and job replacement. The future investment is nothing but the global investment in AI. So the global investment in AI are rapidly expanding about the project. Many projects are going for $1 million rate and all. Many public notification has been happened. Moreover, the funded project like SERP, DRDO, AIMS, and ICMR projects are future investment. How to improvise the healthcare via using AI. So industry like finance, transportation, defense, healthcare are driving a massive funding how to improvise the best treatment plan in finding the diseases and nullifying the occurrence of the diseases. So many startup and research labs are still doing investigation in the private sector and the government sector to support the AI innovation. And the researchers is expanding in AI role, the machine learning in terms of robotics, because with the help of robotics, lot many challenging surgeries has been happened, and everything comes in a very good success rate. 98.99 success rates has been happened with the help of AI in robotics for surgeries and all, where the human intervention can be found in a very minimal. So with the help of AI, many researchers has found a very good information in climatic change, drug discovery, and having a public safety programs and genomics and all. And moreover, the researchers have focused on many with the help of AI, with the help of ethical AI, and there's more things can be applied with the help of explainable AI, human AI collaboration to ensure the safe age of the future dynamic environment. So with the help of massive data count, how the information has been spread, how many persons are willing to accept those data, how many percentage are unwilling, and many more, there's neither willing or non-willing. So according to the acceptance worldwide opening receiving, AI-enabled healthcare is very welcome in all part of the globe. So this chart explains about the things, what is happening in the world. So this chart highlights a global consumer toward the AI-enabled healthcare. So there are many respondents under different levels. So when you come to 100% page, 54% are welcoming this AI-enabled healthcare, and 38% are not willing for this AI-enabled healthcare, and 7% are not giving any vote for either neither they are willing or non-willing. They are not showing much interest. In that way, this particular things has been happened. So investment in AI, artificial intelligence, nothing but according to the research firm Allied Market Research, AI in medicine market has valued $719 million in 2017, but research aspect they are expecting $18 million, 18,119 million at the end of 2025. That is a remarkable contribution of AI advancement. And one more analysis has been found in AI application is approximately in the year of 2026, we can able to save 150 billion in the healthcare cost annually by USA. According to survey of USA researcher, they found that we can able to save $150 billion. So supporting tools of AI, how to interact with AI in the healthcare system, how security and privacy of patient care data as a maintain means, will be collecting the data under very secure environment using electronic health record with proper history of the patient details and all should be collected. It provides a lab result, history, prescription, everything. Medical imaging and scanning, X-rays, MRI, CT scan. It has wearable IoT devices, heart rate monitors, glucose monitor, and it has genomic database, DNA sequencing for precision medicine. And moreover, example is of this AI is data collection is nothing but in the diabetic situations and all, how the data collection is very much important to maintain the percentage of diabetic level. For example, the diabetic stage 1 is there, stage 2 is there. So based upon this glucose sensor only, I can able to find out what is the stage of the patient, what are the treatment plans should be done, and how the treatment plan is accepting to the particular patient health condition. So based on the health condition only, the treatment plan can be done. In that way, how to improvise the lifestyle of the data. A lifestyle can be improvised with that particular input. So everything can be done efficiently with the help of AI. And moreover, in data processing analysis, this AI model processes large heterogeneous data for diagnosing, detecting the cancer at the earlier stage, predicting the cancer cell, and you have to provide a very good splendid data decision support services, and how the interaction, how the what to say, how the interaction has been happened with the help of direct integration between the patient to the doctor, doctor to the hospital, and the patient to the hospital. Everything can be processed in a very good amicable manner. The third one is integration into clinical flow. So AI tools are embedded into the hospital management system for patient triage and bed allocation. And moreover, you have to provide a critical, very good decision support system in the clinical. How the doctors are very much providing a services with the help of AI insights and all, and whether they are going for robotic surgery under real-time environment or remote monitoring environment. In that way, you can able to choose it. So how the security and privacy are ensured? By using encryption, proper encryption should be done, protecting the data by using a very safest algorithm, that is advanced encryption standard. And data is transmitted by a secure communication between the devices and storing in the cloud API services and all. And whenever you're going to share the information, everything should be done end-to-end encrypted should be done. And how to provide the access control? Access control can be done in any way using what to say, in terms of doctors, nurses, building the staff, admins. One can see the data necessary for the job. And multi-factor authentication is very much important for verification of the building processing system. And there may be a least privilege principle. The user should have a minimum needed requirement for taking the privilege and all. And that's a proper auditing and monitoring will be done to maintain the patient records, details, and billing payments and sensitive information data about the patient illness condition and all. Only an authenticated through authenticated environment only I have to share the data only to the respective patient, not apart from the patient. And they should be able to it should be cover the HIPAA and GDPR laws regulation according to the US and health and Europe law. Let me discuss in detail about the HIPAA and GDPR. So both the regulation aim to protect the patient security and privacy. So HIPAA is nothing but Health Insurance Portability and Accountability Act according to the US. What do you mean by PHI is nothing but protected health information. For example, if a patient name, all the names, medical information, medical history, and the family details and the insurance policy about the patient treatment plan, what is the illness stage level, what are the imaging sections are there, scan reports are there. Everything should be preserved under the act of HIPAA. That is very much important. Patient security is very much important. Patient data security is very much important for the handling the from the hospital level. And moreover, privacy rules very much important. Always keep care of the health information of the patient in a very secure manner. There should be a trust and there's a limit in disclosure should be there. And moreover, security rules are there. Only administrative staff, the technicians safeguard the physical, the safety system for data insurance and all. According to the Europe law, there is GDPR Act. Personally identified information covers all the information about the data, patient data, and data should be keeping utmost care. And there should be a concern in processing the healthcare data. And the patient can able to, based upon the patient request, they can able to save the record or they can able to delete the data based upon the patient things only. And data minimization is nothing but collect only when data are required for the particular patient for the treatment purpose only. Apart from that, data storage should not be entertained in the particular things. So these are the two things, laws which plays a very important role in the patient data care system. And next one is how security and privacy are ensured. So data protection and encryption is very much important for So strong encryption methods request for storing the data and for transmission of the data from one end to the other, from one server to the other server or one location to other location, and access control only through a safe and secure mechanism. And monitoring this data can be done in auditing and monitoring the compliance with the regulation. How security and privacy ensured by using the AI tools. So data security and privacy frameworks ensure the security of data. Encryption should be done with the patient record. These are things we have discussed earlier. An example how the data processing and privacy has been systemized in the hospital environment system. So in the central database, you'll be having a image collects the imaging data through MRI scan. So using artificial intelligence, the person can the system can able to detect what are the any abnormalities found. For abnormalities means any uncomfort situation has been happened while detecting the image scan. For example, if tumor has been identified means the AI flag possible tumors and send results to a doctor. Once the results has been sent to the doctor, the AI training update the information about the things of the raw scans and all. So AI will process the image and AI communicates the data along with the detailed insight. So this is how the data processing has been happened in your AI system. So the hospital collects the imaging data from MRI scan. The help of AI to running the hospital server on the cloud, process the image, AI flags, identify the tumor and send the results to the doctor. AI communication are encrypted and log files are stored in the blockchain for auditing, and AI training models will update the information about the raw scans and all. And the conclusion about the thing. The final conclusion of data security and privacy is in the technology that's fast in the fast world, the fastest using the in the fast world, that's a change in technology, change in plan, and change in concepts also. The concepts are more important. The concepts are more important based upon the science fiction, and artificial intelligence plays a very important role, and it
Okay.
plays a main role in a human power and human resources effectively and efficiently. We know that every advancement will be having a lot many merits and demerits, and moreover, with the help of AI, you can able to provide a remarkable suggestion and remarkable splendid advancement for controlling the process. With the help of AI, dehumans the warfare of using AI technology can kill the humans without involving the human. AI won't serve, because with the help of human intelligence only the human AI plays a very important role in healthcare industry. So all the judgments based upon the accountability of their work remains questionable. As we accepted computers digitalization and dependency upon the internet, through AI we can able to bring a very good revolution in the healthcare sector. So with the help of this, we can able to provide a data security and privacy based upon the streamlined device. So everything should be have a safer zone with the help of HIPAA Regulation Act according to the US Act and GDPR according to Europe Act. All the secured information should be taken utmost care, and there should not be any anomaly found in any direction. And furthermore, you can have an integration of privacy preserving AI methods such as federated learning and differential privacy and for data anonymization, which ensures a secure monitoring and employee training and instant response planning for further strengthening your cyber threats. So what are the future enhancements can be performed in AI healthcare interaction means using a federated learning and imaging, you can able to collaborate with the tumor detection, any kind of tumor with raw MRIs and all. With the help of AI and Internet of Medical Things security, we can able to provide a very safer, secure communication protocol, basically based upon the digital image, that is a wearable medical device, any gadgets and all. With the help of blockchain-based auditability, we can able to provide transparent tamper-proof audit trails for healthcare data access. And using a secure architecture, with the help of combination of blockchain and federated learning, you can able to provide a model updates. With this, I'm ending my session. Yes, any questions? I thank Rekha ma'am for giving an opportunity.
This is an important note. The feedback link has been provided in the chat box. We request all participants to kindly submit your feedback form as it holds immense significance in refining and enhancing such academic endeavors. I repeat, the feedback link is provided in the chat box. We request all participants to kindly submit your feedback form as it holds immense significance in refining and enhancing such academic endeavors.
Yes, thank you, ma'am. Thank you for giving this opportunity.
Thank you very much, ma'am, for your inspirational and empowering message. Your emphasis on research innovation, academic excellence, and the role of women in technology has resonated deeply in all with us. Your insights have instilled a sense of responsibility and commitment towards achieving greater milestones in our professional journey. Thank you so much, ma'am.
Thank you, ma'am. Thank you so much.
This is an important note. The feedback form link has been provided in the chat box. We request all participants to kindly submit your feedback as it holds immense significance in refining and enhancing such academic endeavors. I repeat, the feedback link has been provided in the chat box. We request all participants to kindly submit your feedback form as it holds immense significance in refining and enhancing such academic endeavors. At this juncture, it is my earnest duty and immense privilege to extend our collective gratitude to all the three esteemed resource persons, Engineer V. Arun Kumar sir, Engineer M. Nagarajan sir, and Dr. A. Gayatri ma'am. Your valuable time, intellectual contributions, and encouraging words have elevated this valedictory ceremony to distinguished level. On behalf of our management, principal, HOD, faculty fraternity, and participants, we express our heartfelt appreciation for your gracious presence and for sharing your education with us. This day will be attached in our memories as an inspirational and momentous occasion. Thank you, ma'am. Thank you, sir.
Thank you, ma'am. Thank you so much.
An important note, the feedback sessions feedback link has been posted in the chat box for all three sessions. I request all the participants to fill the feedback form as soon as possible and submit it as soon as possible as it holds significance in refining and enhancing such academic endeavors.
Ma'am, I have one question. The exam will be taken on the portal or in the Google form over here?
It will be taken in the portal, sir.
Okay, ma'am. Thank you.
So kindly open your portal, sir. Feedback form is also there, sir.
This is an important note. Both the test questions and the feedback form will be available in the official website in the participant login. Kindly do check it out. This is an important announcement. Only if you attend the online test and submit the feedback form in the official website, which is in your participant login. And the feedback form should be specific and it is mandatory for the certification. This will be your break, and all the participants are requested to join again at 7:45 p.m.
Ma'am, shall we
7:25
start the
p.m.
test now? Excuse me, ma'am. Shall we start the test now?
The test starts at 6:30, and all the participants are requested to join at the perfect time.
Ma'am, in the portal, we need to appear for the test marks, right? Excuse me, ma'am.
Sir, come again.
For the exams, after logging, we already filled the feedback form. At 6:30, we need to go for the test marks.
Yes, sir.
From where we need to appear for the exam?
Sir, 6:30 sharp will be started, sir.
Okay.
You can do it 6:30 to 7:30, sir.
Thank you, ma'am.
Okay.
Please
And
notify
session
once it gets
continue,
started.
session
Once you
continue
activate
on
the link,
7:30, sir. Validity function.
This is an important note. Before getting into the exam, all the participants are requested to check about your details in the participant login, which is available in the official website. This is mandatory for the certification, so please do check it out. I repeat again, before visiting the online test, I request all the participants to check your details in the participant login in the official website, as it is mandatory for the certification with the perfect details. All the participants are requested to submit your feedback in the Atal portal, which is also the official website and which is available in the participant login. An important note again, all the participants can exit the program right now and come back at 7:25. Welcome back, participants. The test session has now concluded. We will now move on to the feedback session. That feedback form is already available in the participant login. Kindly fill the feedback forms. With immense honor, I now invite our respected head of the Department of Artificial Intelligence and Data Science and the coordinator of Atal, Dr. R. Rekha ma'am, to take over and formally commence the validatory session with her welcome address.
A very good evening to one and all the dignitaries, esteemed resource persons, our beloved principal sir, respected faculty members, and enthusiastic participants. It gives me immense pleasure to extend a warm welcome to each one of you to the valedictory session of our 6 days online faculty development program on cultivating innovation, AI in healthcare, organized by the Department of Artificial Intelligence and Data Science, Magendra College of Engineering, Salem campus, Salem, under the sponsorship of AICT Atal Academy. Over the past 6 days, we have embarked on enriching journey of knowledge and innovation, exploring groundbreaking technologies such as artificial intelligence, machine learning, IoT, deep learning, and their transformating role in healthcare systems. This program has not only broadened our intellectual horizons, but also sparked ideas for future research and real-world applications. Today marks a significant milestone, the culmination of the extraordinary academic endeavors. This valedictory session is not merely a conclusion, but a celebration of collaborative learning, shared insights, and the unwavering spirit of academic excellence. I take this opportunity to extend my heartfelt gratitude to all the participants for their active engagement and commitment, which have truly made this program a success. Yeah, as part of this session, we are privileged to have with us our respected principal sir, who will deliver the valedictory address and share his insightful reflections at the end of the program. His words will undoubtedly inspire and motivate us to continue our pursuit of innovation and excellence in the field of artificial intelligence and healthcare. So without further delay, let us proceed with the next segment of our valedictory address will be delivered our principal sir. Welcome you, sir.
Thank you, ma'am, for that gracious and eloquent welcome. Now, with profound respect, I invite our Honorable Principal Sir to deliver the valedictory address.
Thank you. Thank you, one and all. So, first of all, I thank the AICT for sanctioning this wonderful program for conducting on behalf of our institutions. And also, I congratulate the head of AID, Artificial Intelligence and Data Science Department, Dr. Rekha, for applying this wonderful program and got sanctioned. And also, along with him, I have the other members, co-coordinators, Indumari, and other faculty members and students members who have contributed wonderfully for this 6-day journey. I think these are the marathon sessions, how they took their the pain of conducting this event on online and at the same time in the evening hours to coordinating all the speakers and also bringing all the participants in the single platform, conducting this wonderful program and much needed program for the faculty members and they wonderfully organized and conducted this event. So first of all, I thank and also congratulate the HODs and coordinators, co-coordinators, other faculty members, students members. First of all, congratulate and thank you also. So, first of all, the guest, esteemed faculty members and participants. So, as we going to conclude this faculty development program, that is cultivate innovations, artificial intelligence in healthcare system. So, you must take away certain points based on the topics which have been gone through the various sessions. So, just pinpointing certain directions and points. So one hand in the healthcare is on crossroad. So we have never known more about the human body, disease mechanism, and treatment options. We have mapped the genome or developed mRNA vaccines in record time and extended life expectancy across much of the globe. But on the other hand, we face immense challenges like aging populations, rising chronic diseases, health disparities, workforce shortages, and unsustainable costs. In many parts of the world, the access to quality care remains a distant dream. All of you know that how the people are struggling for getting the quality the Medicare system. So in this aspect, how to bridge the gap? So that is the innovations which need to apply this technology with the healthcare system. So this is a wonderful topic has been chosen by the organizers and also the sanctioned by the AICT. So I think the faculty members has undergone all the take away the good points that the speakers are given the all the 6 days. It's, wonderful things. So AI is just not only the tools we are not going to see that this is a transformative potential, and we have to be explore the vast potential of this AI in revolutionary healthcare systems. So you know that how can we bring based on the speakers who are all uh, deliberate in all the sessions, how can it the possibility of the innovations applications, so that also discussed by the during the sessions. How can you apply in healthcare, including the medical imaging and clinical decision supports, and how to engage the patients through this AI. So these are the things you are all expertise on the. I mean, know all these 6 days, and of course we are having other challenges and also having an opportunities also. What are the challenges you know to come across? So we identified the challenge. All of you know that the data quality of the data is very important as far as the this healthcare system. So without the quality of the data, it's not at all possible to take care of the health for the individuals, and including the regulatory frameworks. This that is the ethical point of view, like the cyber security that are all involving. So we had to be involved in ethical way of doing all those things. So at the same time, we having wonderful opportunities in these areas. How can you bring the innovations and growth so that this technology blended with the healthcare system can be able to giving a lot of benefit to the social, I mean, the society. And at the same time, it is not only the just in technology aspects. There's a lot of opportunities available. The way of you have to be doing interdisciplinary collaborations, like encouraging collaboration between the healthcare professionals and the artificial intelligence researchers and industry experts to drive innovations. And the same time, the lot of R&D going is in this aspects. So how can you personalize the Medicare system for individual? So many things is going on. I think I may not be take much of your time because all of you, the expert members have done many things or elaborated all the things. So only my humble request is all the participants. So you have to be take all these points in such a way that so how the valuable this valuable platform given a knowledge, or we have to got all the knowledges and sharing these knowledges with your students, and take these knowledges to the take bringing in innovations, and so that these innovations will be beneficial to the students community. And also the same time, you because of this networking, so you can get a lot of the contacts or the knowledge sharing platform you have established, so that you can I mean can contact those peoples, get then and there get like clarify with your any insights you are coming and get clarified those things. So the main thing is you have to be cultivate the innovations, not only the to the faculty members. You empower yourself as a faculty member on these areas, and take this all these things to the students, and empowering those the students also, so that the students having a plenty of the energy, they can bring up a lot of potential and also giving a lot of benefits to these societies. So this is I would like to convey. So I think all of you have been enjoyed, both the faculty members and organizers have enjoyed all the sessions. Definitely, it is a good topic, and also it can be taken away not only just for got the informations or knowledge, but only thing is the participants how you can utilize these knowledges and take them to the society. That is very, very important. As a closing remarks, just again, I return to where we began. The healthcare is fundamentally the human. No algorithm can replace the warmth of the hands on shoulder and the comfort of listening the air or courage of caregiver working through the night. Also, the AI can, artificial intelligence can analysis and predict and assist, but only the humans can care. So as we cultivate innovation, let us never forget the heart of medicines, that is compassion. Let us build AI system that don't just make healthcare systems smarter, but kinder. Let us innovate not for technology's sake, but for the humanity's sake. That is very important. And let us remember the greatest breakthrough are not measured in lines of code, but lines of improved in suffering, reduced, or in hope restored. So I cultivate boldly, innovate wisely, and always keep the human at the center. That is very important. So thank you, Ronald, who are all contributed, make this wonderful FDP program successfully. So once again, I congratulate the Department of Artificial Intelligence and Data Science and the department head and faculty members are conducting this wonderful FDP program successfully for these 6 days. Thank you, Anandal, for giving these opportunities. Congratulations for all the faculty members also. Thank you, Anandal.
Thank you for motivating and visionary address, sir. To articulate our collective gratitude officially, I now Dr. R. Rekha ma'am from the Department of Artificial Intelligence and Data Science to deliver the vote of thanks.
A very good evening to one and all. On behalf of the Department of Artificial Intelligence and Data Science, Magendra College of Engineering, Salem campus, Salem, and the entire organizing committee of this 6 days online faculty development program on cultivating innovation AI in healthcare, it is both my privilege and pleasure to deliver the vote of thanks on this memorable occasion. First and foremost, I extend my heartfelt gratitude to our distinguished resource persons. Day 1, Session 1, Introduction to Artificial Intelligence in Healthcare. Dr. M. Sridevi, ME PhD, Associate Professor, Department of CSE, National Institute of Technology, Trichy. In this session, we learned how artificial intelligence is transforming healthcare through applications in diagnosis, treatment, and patient care. Then session 2, AI in Medical Imaging and Diagnostics, Engineer Dhruva Jyoti Dutta, Academic Programming Manager, Digito Technologies Private Limited, Bangalore, Karnataka. In this session, we learned how AI is revolutionizing medical imaging and diagnostics by enabling faster, more accurate disease detection and analysis. Then day 2, session 3, AI-driven preventive healthcare. Engineer V. Sashikumar, founder, Microsun Technology, Salem. In this session, we learned how AI-driven preventive healthcare helps in predicting risk early and promoting timely interventions for better health outcomes. Then session 4, revolutionary diagnostics with AI. Mr. V. Sashikumar, founder and CEO, Dev Technology, Salem. In this session, we learned how AI is revolutionizing diagnostics by enhancing accuracy, speed, and early disease detection. Then day 3, session 5, AI-enabled virtual health assistant and chatbot. Dr. K. Suresh Joseph, Associate Professor, Department of Computer Science and Engineering, School of Engineering and Technology, Pondicherry University, Pondicherry. In this session, we learned how AI-enabled virtual health assistants and chatbots improve patient support, provide instant guidance, and enhance healthcare accessibility. Then session 6, AI for pandemic prediction and response. Engineer G. Jayasurya Nyanavel, founder and CEO, Cybernaut EDU Tech Company, Karur. In this session, we learned how AI supports pandemic prediction and response by tracking outbreaks, analyzing data trends, and enabling timely interventions. Then day 4, session 7, AI enhanced remote and virtual care. Mr. V. Yedumalai, project developer, Wings Technology, Salem. In this session, we learned how AI enhanced remote and virtual care improves accessibility, personalization, and continuous patient monitoring. Then session 8, machine learning for disease prediction and risk assessment. Dr. M. Alagiri, Associate Professor, Department of Computer Science and Engineering, SRM Institute of Science and Technology, Ramapuram, Chennai. In this session, we learned how machine learning aids in disease prediction and risk assessment by analyzing patient data to identify patterns and potential health risk. Then day 5, session 9, remote patient monitoring, RPM with AI and IoT. Dr. Maulishwaran, ME PhD, Associate Professor, Department of Computer Science and Engineering, School of Engineering, Dayananda Sagar University Main Campus, Bangalore. In this session, we learned how AI and IoT in remote patient monitoring enable continuous health tracking, yearly alerts, and improved patient care. Then session 10, deep learning and computer vision in healthcare. Dr. Karthik Srinivasan, Assistant Professor, IT, Department of Information Technology, Saudi Electronic University, Saudi. In this session, we learned how deep learning and computer vision in healthcare enable advanced image analysis, accurate diagnosis, and improved treatment planning. Then today, day 6, session 11, wearable technology and AI for real-time health monitoring. Engineer V. Arun Kumar, Master Architect, Hewlett Packard Enterprise, Bangalore. In this session, we learned how wearable technology combined with AI enables real-time health monitoring, yearly anomaly detection, and personalized healthcare insights. Then session 12, natural language processing in clinical data management. Engineer M. Nagarajan, Senior Application Developer, UPS Technologies, Chennai. In this session, we learned how natural language processing NLP in clinical data management helps extract, organize, and analyze unstructured medical records for better decision making. Session 13, data security and privacy in AI-driven healthcare system. Dr. A. Gayatri, Assistant Professor, Grade 2, Department of Information Technology, School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. In this session, we learned how data security and privacy in AI-driven healthcare systems ensure safe handling of sensitive patient information and build trust in technology. For gracing this session with your esteemed presence and for sharing your valuable insights and motivating words, which have truly enriched this event. My sincere thanks to our management, beloved Principal Sir, for his unwavering support, guidance, and inspiring address, which has been a constant source of motivation for us in organizing this program successfully. I also wish to express my deep appreciation to AICT Atal Academy for providing us with this wonderful platform to bring together experts, academicians, and researchers and industry resource persons for a meaningful exchange of knowledge. A special note of thanks to our faculty members for their relentless efforts, seamless coordination, and invaluable contribution in making this program a grand success. I also extend my heartfelt thanks to all the eminent resource persons who through this sessions on cutting edge technologies like AI, IoT, deep learning, machine learning, NLP, natural language processing, computer vision have illuminated new paths of research and innovation in healthcare. To our participants, your active engagement, thought-provoking questions, and enthusiastic involvements throughout these 6 days have made this program truly interactive and impactful. We deeply value our presence and commitment to learning. Last but not least, I would like to thank our technical team, organizing members, and supporting staff, Mrs. S. Indumati and Mrs. N. Thenmozhi, whose behind the scenes efforts ensured the smooth execution of this entire program. As we conclude this academic journey, let us carry forward the knowledge gained, the connections built, the spirit of innovation into our future endeavors. Once again, thank you all for being an integrated part of this enriching experience. Wishing you a continued success in all your academic and professional endeavors. Once again, thank you all.
Thank you, ma'am, for expressing those heartfelt words of appreciation. As we approach the conclusion of this program, I take immense pride in stating that this 6-day faculty program on cultivating innovation AI in healthcare has been an extraordinary confluence of knowledge, innovation, and intellectual exchange. This journey has not merely been an attending sessions, it's about being broadening horizons, fostering collaboration, and igniting a spirit of continuous learning. From day 1 to day 6, every interaction, every deliberation has contributed, shaping more informed and visionary academic community. On behalf of management, Principal Sir, HOD Ma'am, Co-Coordinator Mrs. Indumati Ma'am, Thenmozhi Ma'am, the organizing team, and the entire department, I extend my sincere gratitude to all the participants for your unwavering enthusiasm, active engagement, and insightful contributions, which have been the cornerstone of this program's success. Let us carry forward these feelings, learnings, reflection, and aspirations from these 6 days into our professional endeavors, creating meaningful transformation in the realm of AI and healthcare. Thank you all once again for being a part of this integral part and remarkable academic expedition. Wishing you all a continued success, growth, and innovation in all the future pursuits. Have a wonderful and fulfilling evening ahead.
Well, thank you very much, ma'am. Thank you for these wonderful opportunities.
For a final thank you message, I invite Mrs. Indumati ma'am from Artificial Intelligence Department, also the co-coordinator of Atal FDP, to address the program. Now for a thank you message, now I call upon Mrs. Indumati ma'am from Artificial Intelligence and Data Science, also the co-coordinator of Atal FTP, for a thank you message.
A very good evening to all present here. On behalf of the Department of Artificial Intelligence and Data Science, Mahendra College of Engineering, Salem, and the entire organizing committee of 6 Days Atal Online Faculty Development Program on Cultivating Innovation AI in Healthcare, it is both my privilege and a pleasure to end up the session. I extend my heartfelt gratitude to our distinguished resource persons. My sincere thanks to our management, principal sir, HOD Dr. Rekha ma'am, and our faculty members, those who are supporting to organize the FDP, and our technical team, and my dear students for his unwavering support, guidance, and inspiring address, which has been a constant source of motivation for us in organizing this program very successfully. I also wish to express my deep appreciation to AICT Atal Academy for providing us with the wonderful platform to bring together experts, academicians, and researchers for a meaningful exchange of knowledge. I also extend my heartfelt thanks to all the eminent resource persons who, though through their sessions on cutting edge technologies like AI, IoT, deep learning, machine learning, and computer vision, have illuminated new pathway of research and innovations in healthcare. To our participants, enthusiastic involvement throughout these 6 days have made this a program truly interactive and impactful. We deeply value our presence and commitment to learning. Once again, I thank all for being an integral part of this enriching experience. Wishing you continued success in all your academic and professional endeavors. Thank you all.
Thank you, ma'am, for the address. Now I call upon every participant to rise for national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलति तरंगा तव शुभ नामे जाहे तव शुभ आशीष माहे काहे तव शय दादा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Finally, for concluding, thank you all once again for being a part of this integral journey and this remarkable academic expedition. Wishing you all a continued success, growth, and innovation in all your future pursuits. Having a wonderful and fulfilling evening ahead. Thank you so much.